So good morning, everyone. Once again, welcome back, everyone. So good morning, everyone. A very warm welcome to all of you on day two of our national and international science Olympiad orientation. Yesterday, we started this journey of learning and inspiration, and today we continue even with more energy. This day is a very special because we have with us four wonderful speakers who will guide us with their knowledge, their experience, and their life stories. Each one of them has made important contribution in the field of science and Olympiads. I am sure that all of you students of class 9 to 12 will feel motivated and encouraged after listening to them. So now let me introduce our first speaker. First speaker is Mr. Agam Shah. Mr. Agam Shah is a young achiever from Surat who has made India to proud at the international level. He was a winner at the 55th International Physics Olympiad and one of the toughest competition in the world. Think about it, students. From across the globe, the competition was so tough, and due to the hard work of Agam, he is able to win the silver medal. So currently he is studying at the IIT Bombay, which is a very dream of a many student. His journey tells us about that focus, passion, and determination, it is possible to achieve a great success at a young age. I am sure his talk today will inspire each one of you to aim high and work hard for your own dreams. Let us welcome him with a big round of applause. So, Agam, over to you. Agam, are you there?
Hello. Yes, sir.
Yeah, good morning. Good morning.
Good morning, everyone. So, as sir said, I am Agam Shah from Surat, and I'm currently studying in the computer science department at IIT Bombay, and I also won the silver medal at the International Physics Olympiad 2025. So, I would like to share my journey with you guys about the International Physics Olympiad. So, the first stage of the Olympiad is called the National Standard Examination in Physics, NSEP, which is an objective-based exam, like exam में खाली objective questions are. And basically, so the way I prepared for the exam was the syllabus of NSEP and the JEE exam, which I was also preparing for at that time, matches a lot. And so I didn't need to do much more for particularly for NSEP. What I mainly focused on was solving the past year papers and past year questions of NSEP. So that was my main focus for the first stage, for clearing the first stage. And I felt that if an aspirant is preparing for JEE and targeting the Physics Olympiad, then the past year papers are enough to clear the first stage. Now, the second stage exam, for which around 300 to 400 students are selected from across India, it is a subjective-based exam where you are expected to write complete answers instead of just mark the final answer. In that exam, there are approximately 5 to 7 questions which you have to solve in 3 hours, and they are research-based questions which for which you have to think a lot. And you have to practice those kinds of questions because normally people don't do those kind of questions daily. So for the second stage also, I mainly focus on the past year papers because that is the best resource you have to practice for these exams. And also one of my main goals was to focus on my writing skills, because if you don't, like sometimes what might happen is that you do know how to solve the question, but you are not able to express it. And because of that you might lose marks. So once again, for the second stage, the Indian National Physics Olympiad, INPHO, I think the best resources is the past year papers. From the INPHO, 40 students from across India are selected for the orientation cum selection camp, which is around 15-day camp held at HBCSE, the Homi Baba Center for Science Education, every year. So I was selected for that from INPHO, and then in the camp, what they do is for the first few days they would train you, they would teach you new things, things that you might not have studied before, in and especially the experimental sessions, because until INPHO, the only papers you gave were theoretical, but from OCSE you also have to give experimental exams because there are experiments in the International Physics Olympiad. So in the first few days, they train you, they give you a lot of questions, both theoretical and experimental. They teach you how to approach the questions. And then at the end of the camp, they take a few exams of both, again, theory and experiment. And on the basis of those exams, they select 5 people to represent India in the International Physics Olympiad. So for the OCSC, I once again mainly focused on the INPHO past year papers and the IPHO past year papers. And also in the up till INPHO, that this is not an issue, but in OCSC there are a few topics that are not in the JE syllabus. So I also focused on those topics. And also my physics teacher helped me a lot, and the teachers at HBCSE helped a lot. Then once I was selected for the Indian team to represent India at the International Physics Olympiad, the 5 of us, the Indian team, were invited to attend a pre-departure camp just before the IPHO. And so again, that was around 15-day camp at HBCSE where we were trained for IPHO. So the teachers at HBCSE helped a lot. Like we performed a lot of experiments in that period, and also attempted a lot of questions both of IPHO and other physics Olympiad that might be useful for IPHO. Then once after the pre-departure camp, we left for IPHO. This year, the International Physics Olympiad was held in Paris, in France. So again, it was an 7-day event from 18 to 24 July 2025. And there were a total of 2 exams in IPHO, one 5-hour theoretical exam and another 5-hour experimental exam. So in the experimental test, we were asked 2 experiments to be performed in 5 hours. And in the theoretical exam, there were 3 questions to be attempted in 5 hours. But of course, the 3 questions had a lot of sub-questions as well. And so also, like in IPHO, apart from the exam, there was a lot of fun activities arranged for us as well, and visits to different museums and schools and universities and stuff. And I think it was one of the best experiences of my life. And I don't think that so many people from across the globe, like, I don't think there would ever be another opportunity where so many people from across the globe are united for the love of physics. So, yes, I think that it was one of the best experiences of my life. And I think that everyone should definitely at least try giving the physics Olympiad and attempt preparing for it and seeing how they do.
So thank you, Agam. It was really very nice to share your experience. Like, you have a really very good experience, and you won the even silver medal. That is a very big thing for Gujarat and for even India. Even
Thank you, sir.
and currently you are pursuing your bachelor at IIT Mumbai, which is a dream of many students. So once again, I'm congratulating you for your future endeavors. So thank you very much, Agam, for being here.
Thank you, sir.
Thank you. Thank you. So now we are going to start with our next expert, Dr. Amrit Krishna Mitra. So Dr. Mitra is a well-known teacher and researcher in the subject of chemistry. He is an assistant professor and was the founder of a founder head of the chemistry department at the Government General Degree College, Singapore. He has done in his PhD in organic chemistry and has published more than 45 research papers in the international journal. He has also written books and guided many students for the PhD as well as a postgraduate program. Amrit sir is a pioneer member of the International Chemistry Olympiad, and Dr. Mitra has been a scientific observer and jury member for the Indian team at the International Chemistry Olympiad. First in the Riyadh 2024, then in Dubai 2025. His work is not just about teaching chemistry in the classroom, but also about helping young students like you to perform at the world stage. He has also received many awards for his teaching and contribution to the Olympiads. We are very happy to have Dr. Mitra with us today. So, good morning, sir.
Thank you, sir. Good morning. Am I audible?
Yes, sir. You are audible, sir.
Oh, I'm just sharing my screen. Is it visible?
Yes, sir. It is visible, sir.
Okay, so thank you for your kind introduction. Today I have designed the title of my presentation in this way, from problems to insights, navigating the NACC roadmap. So what I will do, today I have near about 1 hour 45 minutes time as per the schedule, and I'll try to cover the first stage of the Chemistry Olympiad, as Mr. Agam Shah also mentioned, that is the NAC exam. NAC is the first stage of any Olympiad. Since I am focusing on the Chemistry Olympiad, so the first stage will be known as NACC, National Standard Examination in Chemistry. So let me throw some light about the journey of discovery, that is the National Standard Examination in Chemistry. National Standard Examination, NAC, is the initial phase of participation, assessing students through standardized testing mechanisms nationwide. The eligibility criteria is quite important because eligible candidates must be between classes 8 to 12, with requirements varying by subject discipline outlined. Participation statistics. So for the past few years, what we have observed, that over 45,000 students from approximately 100 centers participate in the NAC exam across our country. Now the question will be there, that what is the NAC examination format? The examination structure overview basically tells us, just in chemistry it includes 48 multiple choice questions designed to assess comprehension of senior secondary science concepts. Now, apart from these 48 multiple choice questions, I must say there are 12 more questions where more than one answers are correct. So overall 60 questions are there. Now, to discourage random guessing, incorrect answers lead to negative marking, affecting overall score outcomes significantly. So negative marking is there. Students should be careful about putting a tick mark on the answers. Now the question arises about the subject coverage. This particular examination evaluates knowledge across astronomy, biology, chemistry, and physics at class 12 levels comprehensively. So if you are interested for Physics Olympiad, then you need to appear for NACP. If you are interested for Chemistry Olympiad, then you need to appear for NACC. And you know that there are many students who usually try to attend in more than one such examinations. Maybe some student is interested for physics as well as chemistry as well as for biology. So the examination schedule is prepared in such a way so that no overlapping is there, so that a student can appear for more than one examination according to his or her wish. The eligibility criteria for NAC. The participants must be citizens starting in classes 8 to 12 with specific age limits enforced. And you will get all the details in the HBCSE website, and along with HBCSE, you will all get the authentic details from the IAPT website, Indian Association of Physics Teachers, because IAPT is mainly responsible for conducting such type of NAC examination. Now, there are some age restrictions. Students must not exceed 20 years of age as of December 31st of the examination year. OCI student provision. Overseas citizens of India may participate provisionally, ensuring equitable access to opportunities. Now, I am trying to focus on the academic aspects of the NACC. So what I have done, I have selected a few problems from the previous year's NACC. As you know that in NACC, what we usually observe that one answer correct or more than one answer correct problems are there. So what I have done to share with all of you, actually I wanted to give you an idea about what type of problems usually feature in the NACC examination. So what I have done, I have collected near about 15 to 20 problems from the previous year's NACC examination. And I'll try to focus on the pedagogical aspects, what are the concepts being tested, using those particular problems, all these aspects. So let me first introduce you the first problem. The first problem is like this. The largest number of hydrogens can be interchanged for deuterium when treated with KOD in D2O by 4 distractors are there. A is 3-methyl-1,2-cycloheptane-dione. B is 2-methyl-1,3-cycloheptane-dione. C is 5-methyl-1,3-cycloheptane-dione. And D is 6-methyl-1,4-cycloheptane-dione. So please let it be clear that I am not discussing the problems along with the answers. So my target is quite different. What I am trying to mention, that what are the concepts being tested with the help of this problem, because all of you have some idea about the 11th or 12th standard syllabus. So what are the concepts being tested using each of these problems? That is my focus. For example, through this particular problem, the concepts which are tested are the enolate chemistry and the acidity of alpha hydrogens adjacent to carbonyl groups, the structural influence on tautomerism and exchange reactions. Now the question will be there, apart from such concepts, what are the cognitive levels? Higher order thinking is very much involved in this problem, and it requires not just knowledge of ketoenol tautomerism, but also structural analysis of diketones. Because you know that in this particular problem, 4 distractors are given. So the students need to draw all the 4 structures, and then they need to do the analysis part. So some higher order thinking skill is very much important, and it requires not just knowledge about simple ketoenol tautomerism process, but the structural analysis is also equally important. You know that while solving such problems, some common misconceptions often creep in. Students may assume that all hydrogens adjacent to carbonyls are equally exchangeable. So this is a common misconception. Some students may count only the number of alpha hydrogens without considering the stabilization by conjugation and with the help of enolization. So this is another common misconception. Now, if you ask me that what is the pedagogical value of this particular problem, I must say that this particular problem is an excellent one for integrating structure reactivity relationship. You know that structure reactivity relationship has been an integral part of organic chemistry curriculum. So this particular problem well addresses the structure reactivity relationship. Obviously, such problem encourages visualization of possible enol or enolate forms. Obviously, this particular problem can test whether students can apply general principles to less familiar structures. You know that while framing the distractors, some of the distractors are quite tricky, and students, most of the students are not well familiar with the structure of the molecules given. So the students need to draw the structure, students need to think about the structure, then only they will be able to answer this particular problem. Now, I'm not sure that how many teachers are attending this particular event. So if some teachers are attending this particular event, I have noted a few points so that this type of concept or this type of problem could be extended in our teaching curricula. For example, we can ask students to draw all possible enolate resonance forms, because you know that although these problems are featuring in the past NACC papers, but if we want, as a part of teaching fraternity, we can discuss all these problems with our BSc students, and some of the INCHO problems, that is Indian National Chemistry Olympiad or International Chemistry Olympiad problems, could be discussed even with the master degree students also. So while discussing this type of problems with our students, we can ask our students to draw all possible enolate forms and to draw all possible resonance forms. We can ask our students to compare linear versus cyclic diketones in terms of exchangeable hydrogens. So these are the important teaching extension. And along with these 2 points, we could lead into discussion on keto-enol tautomer ratios and isotopic labeling in mechanistic studies. So you know that in this way we can discuss a single NACC problem. So we need to highlight the teaching extension part. We need to discuss the pedagogical value. We need to discuss the common misconceptions, and apart from that, some other parts are also there. Let me focus on the next problem. Can you see the next problem? Is it visible?
Yes, sir. It's visible.
Okay, thank you. So the next problem is like this. Parachloroaniline on treatment with acetic anhydride in pyridine yielded a mixture of 94% of parachloroacetanilide contaminated with 6% unreacted amine. Among the following, the best used methodology to purify the parachloroacetanilide is to wash the solution of crude product in ether with. Now 4 distractors are there. You know that in Olympiad, that is for the first stage, that is NACC, I am talking in terms of chemistry. In NACC, multiple choice problems are there, MCQs are there, and 60 problems are there. Among 60, 48 are one answer correct, and 12 problems are more than one answer correct. And then comes the next stage, that is the Indian National Chemistry Olympiad, as Mr. Shah has mentioned just before my presentation. So what we found in the second stage, some subjective problems are there. And you know that most of the problems are research-based problems, and most of the problems are contextual problems. Usually, while teaching in the 12th standard or while teaching in the BSc or MSc standard in our country, we do not usually find such type of contextual problems. So in the Indian National Chemistry Olympiad as well as in the International Chemistry Olympiad, you know what happens? the authors of a particular problem, they take a theme from a research paper and they try to modify that particular theme so that it can get the shape of a Olympiad related problem. So the problems are mainly research paper based. The problems are very much contextual. And another point you need to keep it in your mind after the two stages, that is after NACC as well as after Indian National Chemistry Olympiad, that is INCHO, the third stage is OCAC, that is the Orientation Cum Selection Camp. And you know that from OCAC, the practical component is there. So in the OCAC, what we usually do, we teach students in the domain of practical chemistry, because you know that in the International Chemistry Olympiad, practical is playing a crucial role. And out of 100, 40% weightage is coming from practicals and 60% weightage is coming from theory. But the problem is that most of the students who usually qualify Indian National Chemistry Olympiad and who are usually selected for the OCAC camp, as you know that near about 40 to 42 students are selected for the OCAC camp, and in chemistry out of those 40 to 43, 4 students are selected to represent India for the International Chemistry Olympiad. So what we have found that most of the students find the practical domain quite difficult, but no need to worry, no need to panic, because you know that Homi Bhabha Center for Science Education, which is the nodal center to conduct the chemistry Olympiads in our country, they try their best, they arrange all the facilities, they try to groom the students so that they are able to solve the practical related problems, both in the OCAC and if selected also for International Chemistry Olympiad. But in the first two stages, that is in the NACC that I am discussing at this moment, and also for Indian National Chemistry Olympiad, in these two stages, practical components are not there, but you will find that some theoretical problems are usually framed where the concepts of practicals are tested. For example, if some students are present in this meeting, they will be able to appreciate that this particular problem is from the domains of practical chemistry. So the problem I am repeating again, parachlorovanillin on treatment with acetic anhydride in pyridine yielded a mixture of 94% of parachloroacetanilide contaminated with 6% unreacted amine. Among the following, the best used methodology to purify the desired product is to wash the solution of crude product in ether with either methyl iodide or with concentrated brine or with 5% aqueous H2SO4 or with 5% aqueous sodium carbonate. So I have already told you that I am not going to discuss the answers, because you know that all the answers are available in the IAPT website, the answers are available in the HBCSE website and in many other places. So my target is to give you the feel of NACC problems, what are the concepts being tested, what are the pedagogical aspect, what are the normal misconception, and from the teacher's perspective, how can we explore or how can we extend the problem beyond this NACC exam. So what are the concepts tested with the help of this problem? Undoubtedly, the acid-base extraction principle is an important aspect. The solubility differences between neutral amides and basic amines, this is also very important. And if some students are present over here from class 9 to 12, I think they will be able to appreciate that the separation phenomena is an important aspect in chemistry. So whatever research you will be doing in future, maybe in the field of analytical chemistry or in the field of physical chemistry or organic chemistry or inorganic chemistry, you know that separation is a very important parameter. So based on that idea, this particular problem has been framed. Now, the question will be there, what are the cognitive level? Obviously, we must say that it is an application-based problem. The knowledge of laboratory purification methods applied to real scenario. So that is the most important cognitive level, I must say. So there are some common misconceptions. And you know that students may incorrectly choose brine or sodium carbonate, confusing removal of neutral organics versus acidic or basic impurities. So this is a common misconception. The students may think of methyl iodide as a derivatization agent, but that is not practical for purification here in this particular problem. Now, from the pedagogical aspects, I must say that this problem contains high teaching value for experimental chemistry. This type of problem can reinforces the principles. Amines can be protonated and removed as water-soluble salts, while neutral amides stay in organic phase. Obviously, with the help of this particular problem, there is a very good connection, there is a very good bridge, there is a very good liaison has been maintained between theory along with actual laboratory practices. Okay. As I have already discussed in case of my earlier problem, that how teachers like us can extend this type of problem while discussing with our students. You know that we can perform a demonstration experiment in our class or in our laboratory to discuss about the extraction of aniline derivatives. We can link to industrial purification of pharmaceuticals. These are the important teaching extension. We can discuss how workup steps are not arbitrary but carefully chosen. So these type of things are quite important in terms of teaching extension. And you know that while conducting various workshops related to Olympiads, if it is an offline event, I try to design some of the problems in such a way in my PPT so that in front of the students I can perform some hands-on activity so that it can excite the students present in that particular event. So I think that this particular problem, while discussing with our students as a part of teaching fraternity, we can do some hands-on just to encourage, just to boost up the students so that they will become more and more interested to solve this type of problems, and it will indirectly help them to take part for the Olympiad related activities. Now let me move into the next problem. The next problem is the base reagent for converting the amide of 2-phenyl propanoic acid into 1-amino 2-phenyl propane is. So you know that in NACC we try to cover all the parts mentioned in the syllabus. So it is not like that we are going to focus on a particular subtopic. Okay, so you will find that all the parts, all the portions mentioned in the syllabus, they are well covered. They are well covered because you know that the problems I have chosen, because in NACC usually 60 problems are there. So it is not possible for anyone to discuss all the 60 problems of a particular year in a 1 hour 40-minute session like this. So what I have intentionally done, I have taken all the problems and have performed the analysis from a single year NACC, from a single past year NACC, just to show you that there is no repetition of a particular concept. So if you go through the problems, you will get an idea that all the aspects of organic chemistry or all the aspects of inorganic or physical chemistry which are mentioned in the syllabus are mostly covered. That is the beauty of NSCC question paper framing. So with the help of this problem, if I ask any student, what are the concepts being tested? So what will be the answer? What are the concepts being tested? Is there anyone interested to discuss with me? Okay, no one. So what are the concepts being tested through this problem? Obviously, you know, the selectivity plays a very important role in organic chemistry. Selectivity plays a very important role because you know that that a particular organic compound may contain more than one or more than two different functional groups. And suppose I need to perform my chemical reaction in one of those functional groups. So I must try to focus. I must try to focus on the concept of selective agents, the selectivity of a particular reagent. You know that in this particular problem, there is a conversion needed from amide to amine. But you know that 4 different distractors are there and all of them are reducing agent. You know that platinum in presence of excess hydrogen, NaOBr in aqueous base, NaBH4 in methanol, lithium aluminium hydride in ether. So diverse type of reagents are there. So the question arises that what are the concepts being tested? You know that selective reducing agents for amides, the knowledge of lithium aluminium hydride as the standard reagent for converting amides to amines. So these are the basic concepts which are tested with the help of this particular problem. Because you know that in order to convert an amide to an amine, lithium aluminium hydride can be used, and also NaOBr in aqueous base, we may call it Hoffman amide degradation, is also used. But with the help of this problem, students need to draw the structure of the final product first. That is the 1-amino 2-phenyl propane. Then the students need to compare the structure of the product to that of the structure of the mother molecule. Then they need to think whether LiAlH4 is the better choice or NaOBr could be used for this particular conversion. You know that NaBH4 is most of the time is a less reactive reagent than that of LiAlH4. Students need to understand all these things. Then only they will be able to solve a problem like that. Now the question arises about the cognitive level. I must say that this problem contains some memory-based things. Students need to recall the function of this reagent. I must admit that some memory-based or some recall-based components are always there in the JEE or in the NSCC or any other examination, you can say. But in this particular problem, apart from memory-based counterpart, some application part is also present. Students must recall which reducing agents work, and accordingly they can apply it to a specific substrate. Obviously, some common misconceptions are there. You know that while discussing all these problems with my BSc students, I have found that often students tell me that we need to use NaBH4 here. But the students are making mistake choosing NaBH4, basically not realizing that it is too mild to reduce an amide functionality. So it is a common misconception that we encounter while discussing these problems with our students. You know that some students may choose platinum-based hydrogenation, and they assume that catalytic hydrogenation is universal. But you know that here platinum-based hydrogenation will not work. Students are very much familiar with the Hofmann rearrangement. Students are very much familiar with the Hofmann rearrangement, that is the Hofmann amide degradation. And you know that Hofmann amide degradation or Hofmann amide rearrangement, here usually amide is converted to an amine, okay? But during Hofmann amide degradation, what usually happens? Undoubtedly, an amide is converted to an amine, but the number of carbon decreases. But the number of carbon decreases, okay? But the number of carbon decreases. So what happens? That NaOBr may confuse the students with the Hofmann rearrangement. But you know that in this particular problem, the most important aspect is that students need to draw the structure of the final product. Because you have already seen that in this particular problem, the structural representation of the reactant is given, but the IUPAC name of the product is mentioned. So based on that IUPAC terminology, students need to draw the structure. Then they need to count that whether similar number of carbon atoms are present in the product or not compared to the reactant. Then only they will be able to understand whether Hofmann rearrangement will work or not. So these are the common misconceptions that we face while discussing these problems. You know that obviously some pedagogical values are there in this particular problem, because it is a very good way to test whether students differentiate between strengths of reducing agents. You know that with the help of this problem, students can connect organic reaction knowledge with selectivity in reagents. So that is an important pedagogical value. Now, the concept of teaching extension. So if you ask me that how can we extend this particular problem in our teaching curricula, we can ask students to compare the outcome if NaOBr were used instead of giving all those 4 distractors. We can discuss the concept of chemoselectivity. Which functional groups which functional groups are reduced by lithium aluminium hydride versus sodium borohydride. So this type of reactivity selectivity concepts that we can discuss with our students. We could extend to green chemistry by asking what milder alternatives exist in modern synthetic chemistry. I am not sure how many teachers are present or attending this particular event who teach BSc, MSc students. For those teachers, I must suggest that the green chemistry aspect could be discussed with our students. And you know that while discussing this particular problem with my BSc or MSc students, I have found some interesting answers, and some of the students found this problem, found this activity quite interesting in the terminology of green chemistry. Now let us focus on the next problem. And as I have already mentioned, that you know that all the problems are from a particular past NACC paper, and you will see that hardly there is any repetition of concepts, right? And most of the parts are well covered. Since I am from organic chemistry background, that is why most of the problems that I have selected is from the domain of organic chemistry. But if you are not interested in organic chemistry, don't feel bored, because I have also kept some problems from the domain of inorganic chemistry as well as from physical chemistry. But the number of problems from the organic chemistry part is slightly higher. You know that the next problem is like this. Two isomeric hydrocarbons with molecular formula C5H8 undergo catalytic hydrogenation to form hydrocarbon with molecular formula C5H10 as the product. On ozonolysis, followed by oxidative workup, one isomer gave a C5H8O4 diacid, while the other isomer gave C5H8O3 ketoacid. So you know that all this information are given. Now the questions are regarding the structures of X and Y. So if any teachers are attending this event, you will find it interesting that in most of the problems, usually we try to avoid framing the questions using WH words. So the problems are basically statement like X and Y respectively are, then comes the distractors. Then comes the distractors. Now for the students, I must try to share one important point. You know that often in NSCC or often in Indian National Chemistry Olympiad and also in International Chemistry Olympiad, there might be some problems. There might be some problems where a reagent is mentioned that is not covered in the syllabus, or some reaction condition has been mentioned which is also not covered in the syllabus. So in those cases, for the benefit of the students, the authors try to give a small preamble mentioning the importance of that reagent, mentioning the importance of that reaction, so that going through that 2 to 3 line or 1 or 2 sentence based preamble, you will get an idea to solve that particular problem. Okay. So I think I have taken 1 or 2 problems like that where a small preamble is given. I think I have taken, I'll show you later. In this particular problem, the straight problem, and this particular problem is based on hydrocarbon chemistry. So what are the concepts being tested with the help of this problem? You know that isomerism in hydrocarbon is quite important. Isomerism is very important. In this particular problem, there is a competition between the isomerism between alkenes versus cycloalkanes versus alkynes. The reaction-based identification, the concept of ozonolysis, the concept of hydrogenation is there. You know that with the help of this problem, the application of molecular formula and product type to structural deduction has also been mentioned. Okay. Now, if you ask me about the cognitive level, obviously, this particular problem discusses higher order reasoning, and it requires combining stoichiometry, that is the unsaturation index, with reactivity patterns. I think that students are quite familiar with the unsaturation index. I am using the terminology unsaturation index. You know that you can call it DBE, double bond equivalence. You know that when some molecular formula is given, if you calculate the DBE, then you will get an idea about the probable structure of that molecule. Obviously, it will give you an idea to solve such problem. Obviously, some common misconceptions are there. Students may wrongly assume both isomers are alkenes, overlooking possibility of strained cyclobutanes. It is a common misconception. You know that students may confuse ozonolysis products. You know that ketone versus carboxylic acids. Some common misconception I must say. For example, if you have an alkene like RCH double bond CHR, and if you are not performing ozonolysis under reductive condition, then high chances are there that it will be converted to a carboxylic acid. So there are always some confusion between the products formed during the process of ozonolysis. Now comes the pedagogical value. There is obviously a strong interaction of multiple concepts. What are the concepts being tested with the help of this problem? According to me, some formula analysis is there. Apart from formula analysis, reaction-based concepts are there. Along with reaction-based concept, functional group products are there. So these are the pedagogical values usually covered with the help of this problem. You know that I call it chemical detective. So this type of problem I prefer to call chemical detective reasoning. So with the help of 2 to 3 chemicals, we can detect the structure of a particular molecule. I must say that it is an important pedagogical value. Now comes the teaching extension. We can ask our students to calculate degree of unsaturation first. Now we can ask our students to compare ozonolysis outcomes of different double bonds and strained rings. It could have been an important teaching extension. And if you are discussing this problem with your BS or MS students, you could extend into IR or NMR spectrum prediction of the isomers. So in this way, a holistic shape of a particular problem could be given, could be discovered, could be discussed. Okay. Now comes the next problem. This problem appears to be quite simpler. The question is the number of sp hybridized carbon atoms present in 3-methyl, 4-vinyl, 1,2-heptadiene, 5-wine is. So I think that if some students are attending this event, they have already started drawing this structure in the piece of paper. So obviously you need to draw the structure first, and after that you will be able to analyze that how many sp hybridized carbon atoms are present in the molecule given. The concept being tested, you know, students need to have an idea about isomerism. They need to have some idea about the stereochemistry of cumulanes, alkenes, and alkynes. And they also need to have some idea about hybridization. Okay. Structural visualization and careful atom by atom analysis is also important. So these are the important concepts being tested with the help of this problem. Now comes the cognitive level. The first one is application based. You know that with the help of this particular problem, it requires drawing the structures, and then comes the analytical counting. So this is very important. You know that there are some common misconceptions. Students may misinterpret allene centers as sp2 instead of sp. I'm not sure that how many of you are aware of the alene structure. You know that in case of alene or in case of cumulene, and how many sp hybridized carbon atoms are present. This type of practice, this type of understanding are needed to solve problems like this. You know that students often confuse sp hybrid carbons in vinyl groups with those in alkynes. This is another common misconception. Now, if you ask me about the pedagogical value, I'll tell you that this particular problem is an excellent one for enforcing careful molecular structure construction. This is very important. We can train students not to rely on shortcuts, because you know that while interacting with the Olympiad students for the past few years, in the pre-departure camp or even during the orientation cum selection camp, based on my personal experience, I can tell you that most of the students, they are taking training in different coaching centers, and most of them are heavily relying on the shortcuts. But in the HBCSE, or if we understand the motive or the focus of Olympiad, it is not like testing or learning the shortcut techniques. The mission or the objective of Olympiad is to go through the fundamentals, try to understand the fundamental concept, try to focus on the basic things of chemistry, and try to get some pleasure out of it. It is not that to go through some shortcut techniques and to solve some problems. It is not like that. Okay. So I think that we should encourage our students that try to draw such type of structures and try to predict, try to mark how many sp hybridized, sp2 hybridized, sp3 hybridized atoms are present in a molecule like this. Now, in terms of teaching extension, we can have students practice by writing condensed versus expanded structure. You know that as a part of teaching fraternity, it is our responsibility to make teaching quite enjoying. Obviously, it will help us to grow as a teacher. And apart from that, it will also help students to learn the subject in a better way. So, in terms of teaching extension, we can have students practice by writing condensed versus expanded structures. And we can discuss the relationship between hybridization and geometry. So we can give more such structures to our students, and we can tell our students that you know that sp3 means the geometry is tetrahedral, sp2 means it is planar trigonal, sp means it is linear, and we can give 3 to 4 structures, and we can ask the students to draw those structures. In this way, the teaching extension could be done. And we can ask our students to extend the structural part to the molecular orbital diagrams of allenes if possible. I know that the third component will be difficult for the 11th or 12th standard students, but we can easily discuss with our BSc students. Now, the next problem is about NBS. Just I am asking the students to go through the problem. Just try to go through the problem. So in the problem, you will see that there are two sentences. There are two sentences. You know, the first sentence is N-bromosuccinamide, NBS, is a versatile reagent commonly employed for allylic and benzylic bromination via free radical pathway. You know that this first sentence is a small preamble given to you, because as a teacher, as an author, as a paper setter, if I remove the first sentence, then also my problem could be easily framed. I can frame the problem omitting the first sentence. For example, I can frame the problem in this way, that reaction of 1-hexane with NBS forms two isomeric bromohexanes, one of which is 3-bromo-1-hexane. Among the following, the other isomer is. Just try to note down my point here. If I want, I can omit sentence 1, but still I can frame the problem easily. So what is the importance of the first sentence? Because as an author, I might feel that many of the students, they may not know the role of NBS. There may be some students who have not heard of the reagent N-bromosuccinamide. So it will be unfair to discriminate by giving a reagent in your problem that is not known to everybody. That is why we have given a small preamble. N-bromosuccinamide is a versatile reagent commonly employed for allylic and benzylic bromination via free radical pathway. Now, from the student's point of view, if a student does not know the role of NBS, then also based on the one-line short preamble, he or she will be able to solve this problem. So do not need to panic. Just try to focus on the NACC syllabus, try to focus on the fundamentals, try to focus on the basic. No need to panic. No problem will be given to you where some uncommon or unfamiliar reactions are there, or some uncommon or unfamiliar reagents are mentioned. If at all mentioned, please rest assured that a preamble will be given to you, and based on that preamble, you will be able to solve that problem. Okay? Now, what are the concepts being tested using this problem? You know that students need to understand the allylic bromination mechanism, because it is already mentioned in the preamble that NBS reacts via free radical pathway. And you know that when the free radical is generated at the allylic position, it will be stabilized by resonance. So the students need to understand this particular concept first. Then the students need to understand the concept of regioselectivity in free radical halogenation. Because you know that if a molecule has more than one allylic position, the question will be there, among all these possibilities, what is the most suitable position where free radical halogenation can take place? So the concept of regioselectivity, understanding the regioselectivity while performing free radical halogenation is an important concept while solving this problem. Now comes the cognitive level. Obviously, it is an application-based one. And this type of problem requires resonance analysis of allylic radicals. Obviously, some common misconceptions are there. Students may think NBS brominates directly at double bond, like bromine addition. It is a common misconception. Students actually need to understand the mechanistic difference between bromine addition on alkene and the reaction of an alkene with NBS. You know that when bromine reacts with an alkene, it is an addition type of reaction. But when NBS reacts with an alkene, it is basically a substitution reaction on the alkyl part, mainly on the allylic position. As the reaction proceeds via free radical pathway, it will be able to stabilize the corresponding radical. So students need to differentiate the bromine addition and the bromine substitution. Okay. Often students forget that radical delocalization gives multiple possible allylic sites. It is another important misconception, I must say. Now comes the pedagogical value. It obviously reinforces the difference between ionic versus radical halogenation. It encourages mapping resonance structures systematically. Now comes the teaching extension. In class, we can ask our students to draw the allylic radical resonance forms for different molecules. We can give our students molecules like terminal alkenes, internal alkenes, alkenes containing some aromatic unit, and we can ask our students that draw all possible radicals from the given structure and try to compare their stability. We can ask our students to predict the ratios of isomers based on radical stability. This type of concept could be extended to benzylic versus allylic halogenation. So all these things are quite important in terms of teaching extension. Now, let me move into the next problem. I think that all the students present in today's meeting are able to identify the conceptual differences from one problem to another problem. Because you know that we have discussed some selectivity in reducing agents. We have discussed some hydrocarbon-based problems. We have discussed some reactions like ozonolysis, etc., and many others. We have discussed the hybridization type of thing. We have discussed the geometry of the molecules. Now we are focusing on the carbonyl-based transformation. You know that carbonyl functionality is very popular. Based on my personal experience, after going through various competitive examination problems, I can tell you that it is very difficult to get a competitive exam question paper without having problems on carbonyl chemistry. Because you know that carbonyl functional groups are extremely versatile. If your molecule contains one carbonyl group, if your molecule contains one carbonyl functionality, you can go to any other functionality starting from that carbonyl. Carbonyl functionality is extremely versatile, and owing to its immense versatility, carbonyl functionality is popularly known as the queen of organic chemistry. It is so versatile. If you have a carbonyl group present in your molecule, you can prepare any other molecule. That is the beauty of carbonyl functionality. So I think that every competitive exam should contain a few problems based on the domains of carbonyl chemistry. And you know that carbonyl chemistry is so vast. From the student's perspective, you need to understand all the reactions under carbonyl chemistry, and you need to practice the transformations, mainly focusing on the fundamental concepts. For example, this particular problem is to identify the sequence of reagents which would be best suitable for the following conversion. And you know that 4 distractors are there. In the first one, it is different, but in the other one, some similarity is there. In the distractors B, C, and D, you will find that sodium borohydride is common. After that, in B and C, H3PO4 is there. After that, in B and C, Bayer's reagent and potassium dichromate is present, but in D, the other reagents are quite different. So the question arises, what are the concepts being tested with the help of this problem? You know that multiple step synthetic planning, because you know that for this type of conversion, maybe more than 1 steps are required. Now, in the viewpoint of a student, you need to understand the multi-step synthetic planning. That is very important. Students need to understand the concepts related to various organic reactions like reduction, dehydration, dihydroxylation, etc. You know that in the reactant, there is no need of giving any stereochemistry, but in the product, you will be able to appreciate that a stereochemistry of the diol is given. That is an important clue while solving this problem. You know that in many of the NACC papers, if you go through the problems carefully, and if you go through the distractors meticulously, in most of the cases, you will be able to see some hint is usually given. Some point is already mentioned, based on which you will be able to solve that problem. You know that here the clue is the product is a cis diol. So the stereochemical outcome of syn dihydroxylation is an important concept reflected in this problem. Now, in the terms of cognitive level, I must say that it is higher order synthesis planning, and students must mentally sequence the reagents. Obviously, some common misconceptions are there. Students may choose KMNO4 directly, missing the intermediate alkene step. You know that this molecule is cyclohexanone. In order to convert cyclohexanone to cis-cyclohexane 1,2-diol, we need to reduce the carbonyl first. Then we need to perform a dehydration reaction followed by syn hydroxylation. But going through the distractors, students may choose KMNO4 directly, missing the intermediate alkene step. So that might be a problem. You know that the students may confuse between anti versus syn hydroxylation outcomes. Now comes the pedagogical values. Such type of problems are very effective problems that blends reaction knowledge with retrosynthetic thinking. So this point I must say is very important. Very effective problem that blends reaction knowledge with retrosynthetic thinking. You know that while preparing this particular slide 2 days earlier, this particular pedagogical value came to my mind. I'm not sure that how many of the students attending this event are aware of the retrosynthetic thinking. You know that suppose you know a reaction where A and B reacts to give you a product C. You can memorize this reaction even without knowing the details, even without knowing the beauty of that reaction. You can simply memorize the reaction. But you know, the retrosynthetic analysis means the working backward principle. Retrosynthetic analysis means the thinking backward principle. Just by looking at the product, how can you think of your starting material? Just by looking at the product, what strategies could be followed to think about the starting material? So this is retrosynthetic thinking. This is known as retrosynthetic approach. And you know that such type of approach is very important while framing a particular problem or while solving a particular problem as well. For example, since I was informed that 11th and 12th standard students along with 9th and 10th standard students will be attending this event, I assume that some of you might know about aldol condensation. You know that what happens in aldol condensation? If I ask you, what will be your answer? So on behalf of you, I am telling that the answer a student can give is aldehydes having enolizable alpha hydrogen atoms can react under alkaline or under acidic medium to give us an alpha beta unsaturated carbonyl compound. This is an example of an aldol condensation. You know that this is the forward route. Now what will be the retrosynthetic thinking? If someone gives you an alpha beta unsaturated carbonyl compound, and if you are asked to think about the starting material, and if you are asked to think about the starting material, you need to logically work backward to get the idea of your starting carbonyl compound. So this is basically the retrosynthetic thinking. My suggestion to all the students will be, it will be better to study the retrosynthetic thinking process, or to study or to understand the retrosynthetic logic while studying individual reactions like aldol reaction, Claisen reaction, Tishenko reaction, or whatever reaction you have in your syllabus. Another important pedagogical value is to emphasize order of steps in multi-step synthesis. That is another important aspect. Now comes the teaching extension. We can have students attempt retrosynthesis. You know, retrosynthesis means working backward principle. From diol, you can identify an alkene. From an alkene, you can identify an alcohol. From an alcohol, you can identify the ketone. So the concept of retrosynthesis plays an important role while solving this type of problem. And as a part of teaching fraternity, we can discuss all these things with our students. We can discuss stereochemistry of cis versus trans dihydroxylation reagents. For example, OSO4, KMNO4, PAR acids. You know that OSO4 and KMNO4, they help us to get cis diols, but PAR acids can help us to get trans diols. So these are the important teaching extension we could use as a springboard to discuss protecting groups in diol chemistry. That could be another important teaching extension. Okay. You will find another problem. In this particular problem, 4 distractors are given. Our starting material is a terminal alkyne, and from that terminal alkyne, we have been asked to prepare a ketone. Now 4 distractors are given. Students need to identify the correct one. But you know that from a student's point of view, you need to understand all the subparts of a distractor. Then only you will be able to solve this problem. So if you do not know the use of BH3 in THF, or if you do not know the use of HgSO4, H2SO4, or if you do not know the use of PCC in CH2Cl2, or if you do not know the use of 2 equivalents of HBr with peroxides followed by hydrolysis, you won't be able to solve these problems. Okay. So what are the concepts tested? Alkyne chemistry, the concept of hydration, the concept of hydroboration are well tested here. Then comes the concept of Grignard reagent addition to carbonyl compounds. You know that Grignard reagent is very popular in the 11th or 12th standard. And you know that using Grignard reagent, we can perform so many transformations. The reaction of aldehydes, the reaction of ketones, the reaction of many other functional groups with Grignard and with other organometallic compounds are very popular. So that is why a good knowledge on Grignard reagent should be there. Synthetic strategy and multi-step organic transformation. This is another important concept which is tested using this problem. Now in terms of cognitive level, obviously it is a higher order problem solving one. And like the previous problem, this problem also requires the retrosynthetic thinking. So looking at the product, how can I think of my starting material? That is the most important aspect of this problem. Students must mentally map backwards from the target ketone to identify intermediates and reagents. So this is another important cognitive level that can be discussed using this problem. Obviously, some common misconceptions are there. You know that there are some confusion between Markovnikov and anti-Markovnikov hydration of alkynes. We can overestimate the reducing power of NADH4. We can misunderstand the Grignard additions because many students assume that Grignard reagents only react with aldehydes and ketones. It is a common misconception, I must say. But you know that Grignard reagent is a versatile reagent. Grignard reagent not only plays the role of a nucleophile, apart from that, it can also play the role of a strong base. Why am I saying all these things? Because you know that Grignard reagent is a source of alkyl anion. Grignard reagent is a source of alkyl carbanion, and alkanes are the weakest acid in organic chemistry. That means that alkyl anions are the strongest base in organic chemistry. So if your molecule contains terminal alkynic hydrogens, obviously they are acidic. So high chances are there that Grignard reagent can perform acid-base reaction with those terminal alkynes, leading to the formation of various products. But most of the students, they feel that Grignard reagents will react with aldehydes and ketones only. But you know that Grignard reagent can react with esters as a nucleophile. Grignard reagent can react with terminal alkynes as a base. Grignard reagents as a base can react with 1,3-dicarbonyl compounds and many other compounds. It is a versatile reagent, you know. Now comes the clue. I must say that this problem is an excellent one for teaching multi-step synthesis and retrosynthetic analysis. This type of problem can reinforces functional group interconversions and the idea that synthesis is about order of steps. This type of problem can integrate alkyne chemistry, organometallics, and oxidation. Now comes the teaching extension. In class, we can ask our students to draw a retrosynthetic scheme, because you know that in the problem, the starting material was an alkyne. From that alkyne, we are getting a ketone. Now, from the retrosynthetic point of view, that is using the working backward or thinking backward principle, we can ask our students to draw a retrosynthetic scheme. We can ask our students to get the idea of the starting material from the ketone. So from ketone, they can think of a secondary alcohol. From the secondary alcohol, they can think of alkyne hydration type of thing. You know that we can discuss why other sequence of reagents fail in this route. Why a single answer is correct and the other answers are not correct. So we need to discuss all these things with our students. Undoubtedly, such type of discussion will create interest among students. We can show our students how Grignard reagents expand the carbon skeleton. It is basically a key idea in the synthetic design of a molecule. Now let us go to the next problem. In the next problem, I have a 1-butene molecule. We have given peroxide. We are using ultraviolet light and CCl4 is there. And the question is, what will be the measured product? Not only the prediction of measured product is needed in this particular problem, but apart from identifying the measured product, students also need to identify the correct intermediate involved in this particular reaction. Just like the previous problems, 4 distractors are given. So what are the concepts being tested? You know that although I am not focusing on the correct answer, I have already told you, but in this particular problem, the reaction follows a free radical pathway. So here the students need to understand the radical chemistry. that is the peroxide initiation, UV light induced halogenation, etc. So students need to check all the concepts. You know that radical chain propagation involving Cl radical and trichloromethyl radical species is another important concept being tested here. With the help of this problem, predicting major product in a radical halogenation reaction is another important concept. Now, in terms of cognitive level, obviously, this type of problem is an application level problem with some mechanistic reasoning is there, because students need to understand the mechanism in detail. Students need to identify the radical intermediates produced in this reaction, so and so. Obviously, I have found some common misconceptions in this problem as well. Many students confuse this with simple HBr peroxide anti-Markovnikov addition, but here no HBr is present. Okay, so it is another common misconception, because you know that most of the students, they are aware of anti-Markovnikov addition, they are aware of Kharas effect, and this type of thing usually takes place when some peroxide is present in the reaction medium. So many students confuse this with simple HBr peroxide anti-Markovnikov addition, but in this problem no HBr is present. Students may wrongly expect electrophilic addition of CCl4 across the double bond, but that is not the case here. You know that students can misidentify the intermediate, because you know that many students can predict that it is a carbocation, it may be a carbanion, but you know that in this problem, the reaction proceeds with the help of a free radical. Now, if you ask me what is the pedagogical value, this particular problem highlights the importance of carefully distinguishing radical versus ionic pathway. This problem can show how experimental conditions control the reaction mechanism. Students need to understand the role of UV light. Students need to understand the role of peroxide. These are the important pedagogical values. Now comes building mechanistic thinking beyond memorize reagent outcome association. So this is another important pedagogical aspects that can be discussed with the students. Now comes the teaching extension. We can have the students write the stepwise radical mechanism, initiation, propagation, and termination. So we can discuss all these things with our students. Even not only this, we can ask our students to compare outcome with HBr plus peroxide, anti-Markovnikov addition, etc. We can discuss why CCl4 is not inert here, because you know that in different organic reaction, we found CCl4 is mentioned, chloroform is mentioned, carbon disulfide is mentioned, and they are playing the role of the solvents. Because you know that mostly they are inert. That is why, apart from other properties, since they are inert, they are playing the role of the solvent. But in this particular problem, CCl4 is not inert. It is the source of radical, and students need to identify this type of thing. Okay. Now, let me move to another problem. Here, the starting material is paranitrotoluene, and from paranitrotoluene, students are asked to prepare para-iodobenzoic acid, and lots of reagents are given in the distractors. Students need to identify the correct one. What are the concepts being tested? This particular problem examines multi-step organic synthesis planning and knowledge of functional group interconversion. These are the concepts being tested. What are the key concepts? You know that students need to identify side chain oxidation of alkyl benzenes to carboxylic acids, reduction of nitro to amine, diazotization, Sandmeyer related reaction, where substitution of diazonium with halides and Ki here. And this particular test is about recognizing the correct sequence rather than memorizing a single reagent. That is quite important. What are the cognitive levels? This is an application plus analysis. Obviously, higher order thinking is present in terms of Bloom's taxonomy. Students must visualize intermediate structures. They can plan the synthetic route and they can apply reactions sequentially. These are the important cognitive levels. Along with that, it also requires familiarity with named reactions like Sandmeyer type transformation. Okay, so these are the cognitive levels. Obviously, I have found some common misconceptions in this problem also, because often students confuse oxidation order. Some students might attempt diazotization before oxidation, and they forget that oxidation destroys the NH2 group if it is already introduced. Believing direct iodination of aromatic ring is possible easily, overlooking that iodine is a weak electrophile. Forgetting that NO2 cannot be diazotized directly, it must first be reduced to NH2. Misapplication of Sandmeyer reaction is also there. Thinking of iodination uses CUI, but actually Ki alone suffices after diazotization. You know that some pedagogical values are there. With the help of these problems, we can train our students in various retrosynthetic analysis, how to think backward from product to starting material. That is an important pedagogical value. With the help of this problem, we can integrate multiple functional group transformations, oxidation, reduction, diazotization, substitution, etc. Apart from that, with the help of this problem, we can reinforce the logic of sequencing reactions, highlighting that order matters in synthesis. Not only this, I feel personally that this type of problem can encourage the cross-linking between different areas of organic chemistry, aromatic substitution, redox, and named reactions. Now from the pedagogical value, we can move to the teaching extension part. The teachers can ask students to propose alternative synthetic routes, that is via Sandmeyer with CUI or by iodination after nitration or oxidation. We can even extend this theory-based problem to our laboratory work. That is why I have mentioned this, laboratory extension. That is, we can demonstrate the oxidation of toluene to benzoic acid using KMNO4. We can compare different diazonium substitution reactions and why iodination is so special. So we can discuss all these things with our students, and it will undoubtedly make teaching learning quite interesting and engaging. So since I have around 15 minutes of time, I am not discussing the other problems in detail. Rather, you know that all these problems are from the organic chemistry domain, okay? Since I have discussed the problems mainly based on organic chemistry domains, that is why let me move to some inorganic chemistry or one or two physical chemistry problem. So let us focus on this problem. So the problem is, in which of the following compound synergic bonding is found? And 4 compounds are mentioned, okay? So what are the concepts being tested? Synergic pi backbonding interaction in coordination or organometallic complexes is quite common, and the students need to understand this concept, okay? Because you know that the terminology synergic is mentioned in the problem. So the students need to understand this concept. Students need to understand how ligands with pi acceptor ability like CO, C2H4 interact with transition metals. Now from the sigma donation from ligand to metal, that is another important aspect. Pi back donation from filled metal d orbitals to empty pi star orbitals. That is another important concept which can be tested. Recognizing examples of metal carbonyls and olefin complexes where synergic bonding occurs. This is another important concept. You know that the cognitive level, obviously it is application plus analysis. According to Bloom's taxonomy, students must identify the correct type of bonding from the structural formulas or the molecular description given to them, okay? And undoubtedly it requires integration of inorganic chemistry, bonding theories, and molecular orbital concepts. Obviously some misconceptions are there. Assuming all metal ligand bonds involve only sigma donation, neglecting pi back bonding. These are some common misconceptions. Obviously there are some confusion involving simple ionic or coordinate bonding like KPTC2H4Cl3 with synergic bonding. Students may incorrectly include salts. That is another thing. Not recognizing that BH3CO is a Lewis acid base adduct and not a classic synergic bond. You know that believing pi back bonding requires only CO or C2H4 without considering the metal's electronic configuration. That is another common misconception. Now comes the pedagogical value. Obviously, with the help of these problems, we can highlight the metal ligand bonding concepts beyond simple coordination. This type of problem can strengthen understanding of transition metal chemistry, MO theory, and ligand effects. Obviously, this problem can connect theory to practical organometallic examples like NiCO4, which has industrial significance. This type of problems can encourage students to reason about electronic structure, rather than memorizing formulas. These are the important pedagogical values. Now, in terms of teaching extension, we can keep this type of problem with our students, and we can ask our students to draw the molecular orbital diagrams for NiCO4, and we can explain how sigma donation and pi back donations are involved. We can ask our students to compare synergic bonding in mononuclear versus polynuclear carbonyls. Okay. We can demonstrate experimentally or via simulation the bond length changes due to pi back bonding. We can extend to other pi acceptor ligands like phosphines and olefins, showcasing broader application in catalysis. For example, in Wilkinson's catalysis. I am running out of time. I am showing another inorganic chemistry problem here. Which of the following statement or statements is or are incorrect? And 4 distractors are given. So what are the concepts being tested? Obviously, the chemistry of xenon fluorides and xenon oxyfluorides, understanding the reactivity towards water, stoichiometry of xenon fluorine compounds, and molecular geometry of xenon compounds are also important concepts which are tested in this problem. We can link this problem to the VSEPR theory and for the oxidation state and stoichiometry concepts. Now, in terms of cognitive level, the analysis cum evaluation part is an important one in terms of Bloom's taxonomy. Students must apply knowledge of noble gas chemistry, chemical reactions, and molecular geometry. Obviously, with the help of this problem, it requires evaluation of each statement rather than simple recall. The common misconceptions are believing that all xenon fluorides react violently with water, some like XCF2 hydrolyze slowly. Obviously, some confusing stoichiometry, that is Xc plus F2 will give you XcF6, and it requires 1:3 ratio, not 1:5 ratio. So these are the common misconceptions. I am going a bit fast due to lack of time, because you know that I always love discussing the concepts, the misconceptions, the pedagogical things. How can we extend this type of concepts beyond our normal competitive examination domain? But discussing a single problem takes lots of time. And you know, since this is an online mode, this is basically a one-sided way. It could have been better if I could have interacted with all of you in an offline mode, because in that case, interaction would have been much better. So, the misunderstanding of VSEPR prediction is another common misconception. Overgeneralizing the behavior of Xc fluorides without considering oxidation states and ligand effects is another misconception. Because you know, with the help of this problem, some pedagogical insights are there. We can encourage the careful analysis of statements, and we can connect the theory to the experimental observation. You know that if you can feel these pedagogical values, you will really enjoy these problems. It doesn't matter whether you are a student or you are a teacher. The pedagogical insights are really wonderful, and always the authors pay some attention on these pedagogical aspects while framing these problems. And some teaching extension part is also there. So in this way, we can discuss all these problems, okay? So lots of things we can discuss. I am skipping some of the slides. because I need to share some interesting things with all of you. So just give me a minute. These are all inorganic chemistry problems. And you know that in organic chemistry, carbonyl chemistry is very important, and we can expect problems from carbonyl chemistry. But in inorganic chemistry, we can expect problems from coordination chemistry, from chemical bonding. And if you are a student aspiring for this type of examinations, you need to pay attention on these topics, okay? Now I have around 5 minutes left. Just I am showing some colorful slides, and these are the guide to the Indian Science Olympiad. You know that these are the very important points: the introduction to Indian National Science Olympiads, the objectives of the Science Olympiads, the role of Homi Bhabha Center for Science Education, the nodal center to conduct Olympiads, the history of India's participation in Olympiads, and overview of the Olympiad process. I do not have time, but you know that this year the performance of India in all the Olympiads have been wonderful. In some of the subjects, Indian team has received 4 gold medals. In some cases, they have won 3 gold medals. In some cases, they have won 2 gold medals. 2 gold, 2 silver, 3 gold, 2 silver, 4 gold, 1 silver. So wonderful performance this year. And the Honorable Prime Minister of our country, he has appreciated the performance of the Indian team in his Man Ki Baat presentation, you know. And another important thing I would like to share that proudly this year, India was the host for Astronomy and Astrophysics Olympiad, and the closing ceremony held last week. And as an Indian, since I'm involved with the Olympiad process for the past few years, and being an Indian, it's a proud moment for all of us, because you know that conducting an Olympiad as a host, it takes lots of things. And I have seen that how HBCSE was involved in this process for the past 1 year. So the Olympiad took place in the month of August in 2025. But trust my words, when I visited HBCSE last year November, last year December, 2025 January, 2025 February, I have found their involvement, how involved they were. So these are the several stages I have already told you. The main focus of the Olympiad is the holistic science education. Olympiad also focus on practical application. Okay, I have already told you that most of the problems which usually feature in the Indian National Chemistry Olympiad or International Chemistry Olympiad, they are research-based problem, they are contextual problem. And another important aspect of Olympiad is the national and international exposure. Obviously, with the help of this Olympiad, we can identify the scientific talent. You know that it is a gateway of lifelong scientific and mathematical pursuit. I really feel these points. That is why I have incorporated it in my slide. Undoubtedly, not only for the students, I personally feel that Olympiads can enrich the teaching fraternity as well. It can promote excellence in science education, and obviously it can encourage in global collaboration. This is the Homi Bhabha Center for Science Education, the nodal center of Government of India to conduct Olympiads. HBCSE plays an important role. I must say it plays an instrumental role. What I have felt that it has been my second home, because Homi Bhabha Center for Science Education is extremely caring. And all the staff members, all the faculty members, they take lots of care for the resource personnel, for the students, for everyone. So as a student, as a faculty member, as a resource person, you will never feel that you are away from your home, because they are extremely caring. And you know that the HBCSE gets support from DRNS, Department of Atomic Energy, Department of Science and Technology, Ministry of Education, ISRO, Department of Space. And without their help, it would have been difficult to conduct such a big event, because lots of things are involved in the organizational point of view. I do not have that much of time. That is why I can't explain in detail of history of India's participation in Olympiads. But you know that as an Indian, we can take proud that our country has organized all the Olympiads as a host country at least once. You know, India has organized all the Olympiads. Even in the Astronomy Astrophysics Olympiad, they hosted this year. You know that they organized International Mathematics Olympiad in 1996, Chemistry 2001, Astronomy 2006, 2016, Biology 2008, Junior Science 2013, Physics 2015 again, and Astronomy Astrophysics in 2025. And lots of organizations are involved in these Olympiads, and they also support HBCSE. Without their support, I personally feel it could have been difficult. In Chemistry Association of Chemistry Teachers, Indian Association of Physics Teachers, IAPT, because IAPT not only helps the physics fraternity, the domain of physics, they also conduct the NAC examinations. So my heartfelt regards to Indian Association of Physics Teachers, all the members, all the officers of IAPT for supporting Olympiad program in such a way. Apart from IAPT, SCT, I must say the contribution of ATBS. This is the Association of Teachers in Biological Sciences, and many other organizations are there. Mathematics organizations are there. Astronomy organizations are there. These are a few glimpses of the OCSE camps. These are the several stages of Olympiad: stage 1, stage 2, stage 3, stage 4, stage 5. And you know that the most important thing is that as a student, you need to pay a small registration fee. I think it is from last year or from this year, it has become 300. Earlier, it was 200. That is the only fee you need to pay. After that, government will take care for everything. If you represent India, government will do all the things for you. These are the enrollment, right? It is 300. From last year, it has become 300. Earlier, it was 200, and this is the one-time fee, okay? These are the stages. These are the selection criteria. You will get most of the information from the IAPT or from the HBCSE website. These are the selection process. Pre-departure training camps are important, and for all the subjects like chemistry, physics, biology, mathematics, the PDTC takes place at Homi Bhabha Center for Science Education. The achievement of Indian team for various subjects, not only in chemistry, in physics, in biology, in mathematics, has been wonderful. There are some medal winning success stories. I'm not going into the details due to lack of time. These are some students, Mr. Diptar Kohait, Mr. Subhrojit Raju, Ms. Jivana Priya, and most of them, they got medals in the international Olympiads, and after that, they became very popular, they became famous. Apart from being popular or being famous, they have significantly contributed in the field of science and science education in India and also in abroad. The teachers play a significant role in the Olympiad program. Their dedication has been wonderful. Lots of exposure camps are there for teachers. You know that there are some provisions for the female students for the past few years. What we are observing that the participation of female students has significantly decreased. You know that in most of the subjects, the National Steering Committee Olympiads, they select mentors and scientific observers in such a way so that at least 1 or 2 female mentors or female scientific observers are there. Because you know that so much care is taken. I do not know why female students are not featuring in the Indian team for the international Olympiads. The number has significantly decreased. So my request for the female students that try to focus on the NSE exams. Maybe you do not like chemistry, maybe you have more inclination in physics or mathematics or biology. So whatever subject you like, try to appear for the NSE exams, try to represent India for the International Olympiad. You know, it will remain a lifelong achievement or experience for all of you to hold Indian flag in a foreign country. You know that I have shared lots of photographs where Indian delegations are holding Indian flag in Poland, in UAE, in Japan, in mathematics. This is last year. This is the Indian team last year. I was here as one of the scientific observers of the Indian team. You know that it is really a matter of pride to represent your country with medals, with your country flag in a foreign country. Okay, so I think that it will be my honest request to all of you that focus on this NSE examination and try to represent India in the International Olympiad. So my time is up. I am concluding my session here. My heartfelt thanks to all of you, to Dr. Narottam Shahu and to the other organizing board members. My sincere thanks to all of you for giving me this opportunity to interact with all of you. Thank you. Namaskar.
Thank you very much. So now I would like to okay. So thank you very much. So we are going to meet again around 1 o'clock, and the session will be of hello, Amrit sir.
Yes.
Yeah.
Yes.
Yeah. Thank you very much for a very nice and very important session on the chemistry, sir. It's a really very indeed for our students, because from this session they will come to know how to start a preparation and which kind of questions are being asked in the particular competition, and your insights will be really very helpful to them, sir. So thank you very much, sir. So now anyone want to ask any kind of query or any question regarding this ICHO to sir? Okay. Anyone? So I think, sir, in a later part, I will text to you regarding all these questions if anyone wants to ask. So thank you very much, sir. Once again.
Thank you.
Thank you, sir. Thank you. So our next session is going to commence around 1 o'clock. So we are going to meet again around 1 o'clock. Thank you. Thank you. So good afternoon, everyone. So today, in the second session of the orientation program on day 2, we are having a Professor P.G. Kale with us. So let me give just brief introduction about him. Professor Kale has spent his whole life in a teaching and research. He has more than 46 years of teaching experience and 38 years of research experience. He has guided many postgraduate and PhD students and published more than 40 research papers and written books and articles. Professor Kale is also a member of a very renowned societies across like Biology Society and many other societies. Professor Kale is especially important to us because of his deep involvement in the International Biology Olympiad. He has been a leader of the Indian team many times, including in Australia, Japan, Indonesia, and the UK, and most recently in the Philippines in 2025. Imagine the kind of knowledge and the guidance he has shared with the students over so many years. He has also been honored with the award like a best teacher and has a work for the popularization of science outside the classroom. Students, it's a privilege to learn from someone who has mentored so many young biologists of India. So let us welcome Professor Kale warmly. So welcome you, sir. So now I would like to give you some insight on IBO and how students can do the preparation in the biology part and how they can prepare. So thank you, sir. So over to you, sir.
Thank you. Can you all see the presentation? Hello?
Yes, sir. We can see the presentation, sir.
That's great. Okay. Namaskar. It's a pleasure to share with you all my experiences with the International Biology Olympiads. Well, as you have already heard, I'm Dr. Purushottam Kale, currently president of ATBS, which is like IAPT and AT and ACT, a teachers organization. And we are active in conducting the first level examination NSEB with the help of IAPT, Indian Association of Teachers in Physics. Well, I believe you have already heard about the objectives of Science Olympiad movement, but well, let me share a few things from my view. Well, the first thing is that the International Olympiad movement is here to identify, nurture the talent in science subjects, biology, physics, chemistry, mathematics, astronomy, and so on. Well, it also is aimed at pursuing the talented students into learning basic sciences. I always say that what a country needs most is a team of scientists that can connect science with technology and take the country to a higher level, both in science technology as well as in economics. Well, the movement also is to encourage the development of critical analytical thinking and, of course, the problem-solving skills among the students. But the examination as such is targeted at pre-university students. In India, it is the +2 level. Well, there is also a Junior Science Olympiad, and this is for the students that are yet to complete 10th standard. Well, naturally, the first question I believe should be that why yet another competitive examination? Are the students not burdened enough? Well, I believe this is a unique opportunity, the participation in science Olympiads. It's a opportunity for the students as well as the teachers of different countries that participate in the program. Well, the students as well as teachers that attained the international Olympiads, they get a chance to visit the academic institutions and probably a few important tourist locations in the host country, which is besides, of course, the academic, social, and cultural interaction at a global level. Well, they get the opportunity to test abilities against national and international peers and gain recognition for it. Well, the students also get an opportunity to develop lifelong bonds with the peers from various countries. I always encourage the members of Indian team. I tell them, no bother about what color medals they would fetch. But when they are on the stage for receiving a medal, there should be maximum claps. And when they are about to leave, there should be maximum students with the tears in their eyes. Well, what I simply mean is that students should encourage the interactions with other students from different countries, and they must share experiences and they must make good friends that might remain lifelong in their communication. Well, there are many global science Olympiad merits which are multifarious as such. The science Olympiads do not just give entry to the specific degree courses, and therefore there is a lot of freedom to maintain reasonably high standard of the examination. Well, I always have experienced this, that it is not just an examination, it's an opportunity to learn. Because the questions are designed in such a manner that the students are exposed to many new things in the subject. And of course, they can still choose a correct option, correct answer, because they simply have to use their analytical minds and probably the application of what they have already learned, and a good amount of reasoning, and they can surely succeed in attempting the question. Well, another important thing is that there are no set rules, rigid rules about maximum marks that a theory paper or that laboratory task need to be allotted. Also, the importance they would attach to the theory exam and the practical examination also is at the discretion of the host country. Similarly, the thrust areas or the spatial topics a host country can choose of their own. So looking at the expertise they have developed in their country, they can choose the spatial topics as such. And of course, there is also a reasonable freedom in designing the examination as such. Well, the important thing is that the jury members, the escorting teachers from various countries, they sit together and they must develop a general consensus about the questions and the tasks that the students are to be exposed in their international Olympiad exam. Well, the national merits of the global science Olympiad movements would include the advantage that the participating countries they are required to organize the screening tests to select their team members, and there they can form questions which should normally be on the pattern of the international science Olympiads, but otherwise their discretion to discriminate among the students who would be able to perform better for the international science Olympiads. Well, The screening tests in the respective science subjects, they are normally formed by the teachers associations in the respective subjects, and the question should be such that they would be able to discriminate the students, so that the best, most talented students can be chosen for the team to ensure the maximum performance or the best performance at the International Science Olympiad. Well, this also is considered as an academically enriching experience for both teachers, resource persons that are supposed to form the questions, and also for the escorting teachers who take the team to the International Olympiad. So they are exposed to skills of the given country, the resource persons there, and the new questions that are being formed there in that country, and also probably, as I said, the institutions that are there in that country you can visit, and therefore it's a academically enriching experience. Well, necessarily the team members are selected through a definite procedure, and this varies from country to country. Fortunately for us in India, science Olympiads are supported by the government departments, so we have considerably good amount of funds available with us. The first level examination, NSE, National Standard Examination in maybe physics, chemistry, biology, astronomy, and so on, is where the student has to enroll and pay nominal fees. And once they pay that fee, well, they are not supposed to pay any more fees for the second level, for the third level examination. So all the screening tests automatically get covered in that first level registration fees. Well, the directives of the Global Organizing Committee is that the student should not be rigorously trained. Obviously, with the screening tests that we take, the teachers associations together conduct the national standard examination, but they also contribute in the formation of questions and the tasks for the second level examination, which is called Indian National Biology, Chemistry, Physics Olympiads. And finally, the OCS, or what is called as orientation cum selection camp. So in all that, we are normally searching for the talent, that's all. We are not training them in any way except for orienting. Orienting, by that we have to inform them about how the theory tests are and how the laboratory tests are and what skills are needed for the laboratory experiments and so on. And then we conduct the tests and we choose the best persons from among the students who have registered for that subject Olympiad. Well, naturally in every subject the number of participants varies, but ideally for biology it is only 4. So those best 4 candidates are chosen, and they are then called for a pre-departure training program. Now in this pre-departure training program, this is the only opportunity with us to actually train the students. But this camp is hardly of a week's duration, at the most 10 days. And again, there are visa procedures to be completed in that duration, and therefore maybe we get effectively only 5 days, 6 days, at the most 7 days in which to train the students, both theory as well as practicals. my experience personally is that in theory, we hardly have to train the students. They are very good. They are very good in theory. But in laboratories, they are not as good simply because in our school and plus 2 level curricula, practicals are not given too much of an importance. The laboratories are not well equipped. Even if they are well equipped, students are not allowed many a times to carry out the experiment themselves. It's only a sort of demonstration for them. And that is where I believe the performance of the students is weak. And naturally, therefore, we train the students regarding the laboratory skills that are required to face the international lab tests. And the overall period with the students, the interaction with the students is hardly a 15 days. So no rigorous training. It is not taxing for the students at all. And as I said earlier, there are about 1,000 centers at which the first national standard examination is conducted in various subjects. Only about 1 to 5% of the top performers, 300 plus or probably sometimes 400 plus, are chosen for the second level. That is Indian National Olympiad in physics, chemistry, biology, astronomy, and so on. In this test, once again, the best 30-40 students are chosen and they are invited to attend this orientation cum selection camp, which is held at Homi Bhabha Center for Science Education, Mankhurd, Mumbai. And this is supposed to be the nodal agency that the government has appointed to look into the science Olympiads selection and training of the students and sending them to the international Olympiads and so on. This is the nodal agency. So at HBCSC, this camp is held, and here through 2 theory examinations and 4 laboratory tests, the best 4 in biology are selected to form the Indian team to participate in the International Biology Olympiad. Well, the entire procedure started in 1999 when India decided to participate in biology Olympiads. Of course, chemistry also was the same year, and physics, mathematics Olympiads, India was participating even earlier. Well, I have been associated with this Olympiad movement right from 1999. This first year, though we conducted a selection trial, the team was not sent because the International Olympiad Committee asks the country that is participating in newly in the Olympiad to send a team of observers the first year, and then from the next year they can start sending the teams. So the first Indian team to International Biology Olympiad was sent in the year 2000. Since then, every year, except probably for a short break in the pandemic of COVID, but otherwise, every year India has been participating in International Biology Olympiad, and I'm very happy to tell you that every single team member has won a medal. Whether bronze, silver, or gold is another thing, but everyone has won a medal. And because of this, India has successfully maintained a position in the top 10 best performing countries in the International Biology Olympiad. Well, there are several benefits of participating in the biology Olympiads for the students. The students can learn to think logically, get trained in the problem solving capacities. They can interpret the information fast enough, apply analytical mind, and get to an appropriate answer. Also reading the graphs, well, probably paying proper attention to the figures that accompany the questions and so on. So this skill also is learned by the students. Well, their perspective of learning a subject actually broadens up. And that's what I biological sciences, the scientists as well as the teachers who have put up, years of their work in the appropriate discipline of science. And this is, an outstanding advantage for the students. Well, another advantage is that for their performance in national standard examination in biology and Indian National Biology Olympiad, because they represent less than top 1% merit holders of the entire lot that appeared for the national standard examination in biology, and therefore they receive a gold medal. Often one has to be very clear technically. These are the silver medals quoted with gold, but it's a recognition. So they get a gold medal, a certificate, and probably a book prize from the Association of Teachers in Biological Sciences, besides what they receive from HBCSE. Well, the team members, whatever level of success they attain in the International Science Olympiad, they become automatically qualified for KVPY scholarship, and of course for the NIUS program also. Well, these students are likely to be admitted by any and every research-based institution without any entrance examination. And this is, of course, the red carpet treatment they receive. And this also can be considered as an outstanding advantage. Of course, for the professional courses, like probably medicine, pharmacy, etc., this qualification is not considered. It's only for the basic sciences that you continue to learn. So if you do BSc, MSc courses in biology, well, you will get the KVPY scholarship all through your education, and you can choose the institution of your choice, your preferences quite easily because of your participation in biology Olympiads. Well, we also have other honors by different private institutions that are given to the students for their performance in the International Science Olympiads. But I don't believe this is the motive behind participation in, or this should not be at least the motive for participation in the biology Olympiad. Well, the teachers who are the resource generation camp members, or probably the members of examination committee for the Indian National Biology Olympiad, or probably those that participate in the orientation cum selection camps and the pre-departure training camps, they automatically get a chance, they become qualified to escort the students on the International Science Olympiads or Biology Olympiads. So they can become leaders, team leaders, or the jury members, international jury members for this performance. Well, my personal experience is that from the time I started forming questions for the biology Olympiad program, my understanding into the subject, and more than that, why and how to ask questions improved like anything. Probably there are some advantages that automatically come your way. So there are for the science Olympiads, automatically you are invited on their bodies, to form questions. So that's another advantage. So, for example, MPSC or UPSC paper setting. So, my experience is that I have been invited by them to form questions earlier and then edit the questions that have been contributed by others. And even the net state examination, national eligibility test, and the state eligibility test for the teachers. So to form questions for these tests, I have been invited. So this is only because I started forming questions for the biology Olympiad. So this is also an advantage you can consider. Well, once you accompany the students to international science Olympiads, it's altogether a wider array of experiences that you get. You get a chance to interact with the peers, the teachers, biology teachers from other countries, scientists from other countries, and well, there is discussion on questions, and you can show your mettle there and come to realize where your strengths lie and where your weaknesses are, and through that you of course improve. The International Olympiad Committee expects every participating country to volunteer for organizing the international Olympiads. Well, in India, we already have organized the International Biology Olympiad as early as in 2008, I believe. And it, even as in today, considered as one of the best biology Olympiads. I realize so because the teachers from different countries that I met even this year at Philippines, they keep remembering about the International Biology Olympiad organized in India. Of course, I wasn't a resource person for forming the questions therein. In fact, I was entrusted the duty of selecting and training the team. But nevertheless, this was a unique experience for me too. And well, even as in today, as I said, the teachers from various countries, the jury members from various countries remember the Olympiad that was organized in India. And they said that India must organize a biology Olympiad again, International Biology Olympiad again in India. And soon. Well, naturally, when you organize an event of this international quality, there are so many things, right from administration to probably the academics. In every area, we have to work very hard. And through that, again, we have great experience, academic, administrative, as well as, event management and whatnot, every kind. Well, recently, this year itself, we have had the International Olympiad in Astronomy organized at India. And well, probably you must have heard about it from the members of HBCSC who have participated in this camp. Well, so this is another advantage. Now, I believe you must have heard about the international Olympiads from the teachers in other subjects as well. Here is just one sample question paper, or rather not the entire question paper. I have selected just two questions, one from group A and another from group B, set by Switzerland in 2013. I wouldn't consider it to be the best, but well, I just happened to come across this question earlier than other questions, so I chose this question to put in front of you. Well, this is a B-type question. B-type questions are supposed to be little harder, would take a little longer for you to reach to the answers. So here it goes. High levels of triglycerides in the bloodstream. Sorry, this is supposed to be from A type. By mistake, I've written B type, but doesn't matter. You concentrate on the question. High levels of triglycerides in the bloodstream have been linked to higher risks of heart diseases. An agonist, which is an activating molecule, just for reference, it has been called here S. So an agonist S of the receptor Y was observed to reduce the triglyceride levels. How could one convincingly prove that the effect of S is mediated specifically via receptor Y? This is the question, and there are options given here. Generate genetically modified mice which overexpress more than physiological levels, which overexpress receptor Y. B. Generate genetically modified mice in which receptor Y is knocked out, that is deleted. C. Treat the mice with an antagonist inactivating molecule specific for receptor Y. And D. Treat the mice with an antibody that sequesters, removing from circulation, S, which is that activating molecule. So these are the four options. The question is, how could one convincingly prove that the effect of S is mediated specifically via receptor Y? And these are the four options. Generate genetically modified mice which overexpress more than physiological levels, receptor Y. Second option, generate genetically modified mice in which receptor Y is knocked out, deleted. Treat the mice with an antagonist which is specific for receptor Y. Or last option, treat the mice with an antibody that sequesters, that is removes from circulation, the molecule S. So which of these four options can prove that the effect is through receptor Y? Thought-provoking. This is not exactly what is there in your textbooks, but is not altogether away from what you have already learned in your text. So please try and understand. A, option A, which is generate genetically modified mice which overexpress receptor Y. This is naturally not true. False it is. Why? Because even if the decrease in triglyceride levels observed would be more important than with the wild type mice, this is not enough to prove that SY interaction is either sufficient or necessary for the disease. So A is out of question. B is true. And why is it true? If in these mice triglyceride levels increase after addition of S, it is not mediated by Y. If no decrease can be observed, the interaction of S and Y is necessary for the decrease in triglyceride levels. So this is about B. Now, statement C is also true. Why? Because if Y is inactivated by an antagonist treatment with S, that S should not decrease triglyceride levels. It shows that SY interaction is necessary for the decrease in triglyceride levels. If a decrease would be observed, it would show that S mediates triglyceride levels, which would decrease via some other mechanism than involvement of Y. And finally, it is the last option, D, which is false, because even if no decrease in triglyceride level would be observed, this would only prove that S is necessary to decrease triglycerides, but would not prove that it acts via Y. So friends, now you must have realized that, well, the question asked is not entirely something that is new to you. You knew the basics, but only knowing the basics wasn't sufficient. You had to think critically, you had to analyze, and only then you can choose the appropriate answer. Well, in the same Switzerland paper 2013, B-type question has also been chosen. While the glomerular filtration rate, GFR, you are familiar with this, I believe. Glomerular filtration rate is determined by blood pressure in the glomerulus. It does not directly reflect the systemic blood pressure. Instead, a stable glomerular filtration rate is maintained by either dilation or constriction of the afferent, that is flow in, and efferent, that is flow out, arterioles of glomeruli by an auto-regulation mechanism. Again, please try and understand this. In kidney, there is a glomerulus. Glomerulus is a capillary network formed between an afferent and an efferent arterioles. Why and how the fluid from this blood flowing in the capillaries would leak out or would be given out? This is by having more blood coming in than can leave the glomerulus. So for this, you can have the dilation of the afferent arteriole and constriction of the efferent arteriole. So more blood comes in than can leave, and therefore the fluid portion of the blood can be squeezed out. Several drugs interfere with this mechanism as side effects. So the upper things you knew. Now there is something which is added. Several drugs interfere with this mechanism as side effects. Those include non-steroid anti-inflammatory drugs, NSAIDs, that reduce the capability of the afferent arterioles to dilate. So ordinarily, as I said earlier, autoregulation happens through dilation of the bore of afferent arteriole and constriction of that of efferent arteriole. So if NSAIDs are preventing the ability of afferent arteriole to dilate, naturally GFR is going to be affected. ACEIs, again, you have learned this angiotensin system that that helps in controlling, regulating the amount of urine being formed. So ACEIs that inhibit the production of angiotensin II and therefore reduce the capability of the efferent arterioles to constrict. So we have seen two types of drugs. One type, NSAIDs, that would reduce the ability of the afferent arterioles to dilate, and ACIs would inhibit the production of angiotensin, which is going to cause the constriction of the efferent arterioles. Now, while the glomerular filtration rate is determined by blood pressure in the glomerulus, it does not directly reflect the systemic blood pressure. So, sorry. It's the next part. Yeah. Indicate for each of the following statements if it is true or false. A statement: NSAID intake reduces glomerular blood flow. Try and understand me. NSAID, we have already studied that it prevents the dilation of the afferent arteriole. ACEI intake reduces glomerular blood pressure. So this ACEI is preventing the constriction of the efferent arteriole. C. The effects of NSAID and ACEI on glomerular filtration rate may compensate each other when taking both drugs together. And D. While a chronic overproduction of aldosterone can be treated with ACEIs using an aldosterone antagonist, affects the autoregulation mechanism to a lesser extent. Now let us have the discussion on it. Is option A true or false? NSAID intake reduces glomerular blood flow. Naturally, it is true. This is a side effect of NSAID, and this is to inhibit the dilation of afferent arterioles. Hence, glomerulus is unable to increase the blood flow through that mechanism. Let's analyze B, which is ACEI intake reduces glomerular blood pressure. This also would be true. Why? Because if the glomerular filtration rate, which is dependent on the pressure on the blood, and this is not going to be high enough if the efferent arteriole is not able to constrict enough. So if the glomerular filtration pressure is not high enough, renin is produced, which converts the pre-hormone angiotensinogen into angiotensin 1, which is then converted to angiotensin 2 by the angiotensin converting enzyme. This is that ACEI. By inhibiting this enzyme, the ability to constrict the efferent arterioles is reduced. So this is already mentioned in the stem. In addition, the production of angiotensin 2 rises the blood pressure by rising the vascular pressure and rising the production of aldosterone, which itself rises the renal reuptake of natrium, that's sodium, and water. Inhibiting this further decreases blood pressure. So this again is supposed to have studied elsewhere in the effect of hormones, but we have to apply it here. So inhibiting this further decreases blood pressure in the system as a whole. So A and B, we have said, are true. Coming to the next one, C. The effects of NSAID and ACEI on GFR, glomerular filtration rate, may compensate each other when these drugs are being taken together. This is false. Why is it false? While NSAID decreases the blood flow into the glomerulus, ACEI increases the outflow of blood, and therefore both lead to reduction in the glomerular filtration pressure and lead to reduction in glomerular filtration rate. So they will not compensate, but they will in fact aggravate it. So glomerular filtration rate will be adversely affected here. And D option, while a chronic overproduction of aldosterone can be treated with ACEIs, using an aldosterone antagonist affects the autoregulation mechanism less. Now, obviously, this would be true. Why? Because an aldosterone overproduction can be treated by inhibiting the angiotensin converting enzyme, as this leads to a lower level of angiotensin 2, which is a stimulant for the production of aldosterone. However, due to the larger role of angiotensin, a direct antagonist of aldosterone implies a smaller effect, including the one described in the question. So friends, this is how something already known to you, something which is not written anywhere, but you can relate it to what you have studied parallelly in other chapters, and you can get to appropriate answers. So I believe I have spoken for about 30 minutes, and that is what was the time given to me. So thank you, and wish you luck for participating in Biology Olympiad. And well, I am all for you to answer your questions.
So thank you very much, sir. It's a very, very important session for the students of biology as well as the science students, sir. It's a really very important session, and student really gain through insight regarding biology questions. So thank you very much, sir. Is there any students who wants to give have a certain question or query? Anyone is having any kind of query? So no, anyone is there? Okay, no worries, sir. If anyone is having any kind of query, I will text to you.
Sure.
So
Sure.
so I will convey the questions to you, so you can provide me the answer. Then I will again send to them, sir.
Yes, you can share my email address with the students as well. Not the phone number, of course, because that I don't want to reach to the students. But email address, yes, you can
Yeah, sure,
give
sir.
them so that they can communicate with me through emails.
Okay, sir. Okay. Thank you. Thank you very much, sir.
Anything else?
Anything else? Anyone? No, I think.
Well, I would have now a parting remark. Well, again, I'll relate my experience from your state, Gujarat itself. We have had a 10th standard girl making it to the Olympiads, and 2 years consecutive, she participated in the International Biology Olympiad and fetched medals for us. So what I'm trying to tell you is that this examination is not the test of your memory at all. This is how well you can relate what you have learned to the problem solving and interpretation of various facts that would help you in answering the questions at NSEB as well as INBO levels, Indian National Biology Olympiad levels. So I appeal to the teachers who are in attendance to encourage the students to participate in larger numbers. So right from 10th standard, if the students start appearing for NSEB and INBO, obviously they will have better chance even if they do not succeed much in NSEB the very first year. Maybe they have 11th standard in which they can again appear, and 12th standard in which they can appear too. So probably 3 consecutive attempts they have, and they can definitely make it to the international level. I will give you one more example. With a name I can tell you, there was a student by the name Sahal Kaushik. he had participated in the Junior Science Olympiad and had fetched a gold medal in that. The very next year, he appeared for NSEBs in all three subjects. He got chosen for chemistry and biology, and he chose to do biology further. So he got selected for OCS camp. I have always been involved in interaction with the students there. In PDT, once he got selected in the team, in pre-departure training camp, I happened to give him a book. I said, it's a very important book on biochemistry. You read it, about 350 pages book. And the next day he returned it to me. So I obviously wasn't sure whether he has really read through. But he said, yes, sir, I have read it. And he could see that I'm not convinced. So he said, sir, open up any page and ask me a question from that. So I just opened a random page and I asked him, what about this? And he gave a correct answer. I was really thoroughly impressed. And I asked him, how do you read? So he said he doesn't read word by word or sentence by sentence or even paragraph by paragraph. He reads only page to page. So he will look at one page, he will know what is there on that. He will look at the next page, he will know what is there in it. Like that he could read. So in one night he could complete that book. So what I feel is, this is an ability which comes through practice. Of course, it's God's gift. And I always believe that every forthcoming generation is more intelligent than the earlier one. I strongly believe in that because it's a very simple biological principle. Successful, in the struggle for existence, the one that has the best genes would succeed. So naturally here nowadays, physical strength is not needed. What is needed is the brain strength. So every forthcoming generation has got better brains. There is just a necessity to recognize that and act on it. And Olympiads is a very, very good platform for them to discover themselves and improve. So I wish again all the students best of luck, and persuade your friends also to participate in the Olympiad program. You may choose just one subject of your choice from among the science subjects, or you can appear for all subjects. The best thing you can have is some new questions that are not there in any book, any guide that they might be using. And of course you will come to know their answers. So this is again a very cheap deal, I could say, that exclusive questions with their answers be obtained by just paying that registration fees in itself is an advantage. So please appear for the examination. Thank you.
Thank you very much, sir, for your even our one of our student Rudra Pethani.
Yeah, Rudra was with me at Philippines.
Yeah. So he's yesterday he just shared his experience regarding international biology as well as the international junior science competition. So
yes,
really appreciated that part, sir.
Yeah.
Thank you very much, sir. Thank you once again, sir.
Thank you.
Thank you, sir. So our next session is going to start around 3:30, and that is the last session of this event, and that is of the mathematics. The particular session will be taken by Dr. Udyan Prajapati. He is also member of INMO, International Mathematics Olympiad. So he is going to take this session around 3:30. Thank you very much. Please stay tuned. Good afternoon, everyone. Good afternoon, Udyan sir. Sir, am I audible to you? Hello.
Yes, you are very much audible.
Okay, sir. Thank you, sir. So now we are moving toward the last session of the day and last session of the event. And the session will be taken by Dr. Udyan Prajapati. So Dr. Prajapati is the head and associate professor of mathematics at the St. Xavier's College, Ahmedabad. He has been teaching for the last 37 years and has been associated with this mathematics Olympiad for more than 2 decades. He has trained and guided many students, and he was also deputy leader of the Indian team at the International Mathematical Olympiad in the Hong Kong 2016 and Vietnam in 2007. He has published more than 59 research papers, 8 books, and has been honored as the president of Gujarat Ganit Medal. For thousands of students, he has been a mentor and a guide in the mathematics, showing them that problem solving can be exciting and rewarding. With his experience and patience for mathematics, Dr. Prajapati will surely motivate us all to love the subject more deeply and aim for excellence in Olympiad. So thank you very much, sir, for being here. Sir, you are not audible, sir.
Thanks a lot for providing me opportunity to interact with the Olympiad students. Am I audible?
Yes, sir.
Fine. I'm not going in the technical matter of what is how to get in IMO, or if I can spend 5 minutes, couple of minutes for this. To get the IMO, you should get the training at HBCSE Omnibus Center for Science Education about 4 weeks. Now, last 2 years, the training has been shifted to CMI, Chennai Mathematical Institute at Chennai. But to get the admission in that training, 4 weeks condensed training by renowned professors of various reputed institutes of India, you should be able to clear the INMO, Indian National Mathematical Olympiad. Usually, Indian INMO is a national level exam, but in our Gujarat, about 30 participants have been selected to appear for INMO. 30 plus some girls quota, 5 to 6 students, some 12 standard quota. So as a whole, around 40 students are there. They appear in INMO. But to get the admission in this INMO, you should be able to clear the RMO, Regional Mathematical Olympiad. Regional Mathematical Olympiad is conducted by HBCSE Omnibus Center for Science Education, organized by that. And in Gujarat, I am the coordinator of Gujarat region regarding this Olympiad activity. So RMO we have in Gujarat, there are 4 centers: Ahmedabad, Baroda, Rajkot and Surat. So they can appear for RMO. But previously RMO it was an open test. Now it is the filterized by IOQM, Indian Olympiad Qualifier in Mathematics. It is called IOQM. IOQM is a not multiple choice, but you have to write the answer in 2 digits or 3 digits or 4 digits, something like that. If you clear in top 30 of that, you are allowed to, not top 30, you are in top some number, I don't know, remember the number, you are allowed to appear for RMO. And in RMO, if you are in top 30 of the state, you are allowed to appear in INMO, Indian National Mathematical Olympiad. And if you are good enough in INMO, and if you are exceptionally well, because the central level paper is checked, and top 30 of national, they are selecting, and that the 30 students are usually 30 plus girls quota 4 or 5, and 12th standard quota 5 or 6, something like that. So around 40 are invited to attend the training at CMI, Chennai Mathematical Institute. And in that training, there are 4 selection tests. On the basis of 4 selection tests, the merit list is prepared. Top 6 students will be considered as the representative of Indian team to appear for International Mathematical Olympiad of Indian side. This whole chain, once upon a time, was a deputy leader for Indian Mathematical Olympiad in 2007, Vietnam, Hanoi, and 2016, Hong Kong. Last 2 years, our good observation that the Indian team is doing very well. Rank is 10 or 7, something like that. And this year, the 4th rank, something like that. So, now, I was the faculty at the national level to train this student. Once you clear INMO, usually I used to teach. Now the younger generation of faculty also there at CMI, they will teach you if you selected. Shall I speak in English or Gujarati? What is your mixed language, sir?
Mixed language is a more beneficial. Hindi, Gujarati, English, sir. Hindi, Gujarati is the most preferable, sir.
Okay, fine. So usually this kind of exams is a thoda hatke out of box exam is there. It is not even in any standard book you can get the problem. No. Here not a single problem is repeated. That is a flavor. You can imagine that in IMO, there are 2 days tests. 1 day, 4.5 hours. Only 6 questions are asked. So you can imagine only 3 questions are asked in 1 day. So to solve 1 question, you have time 1 hour and 30 minutes, 90 minutes. So you can think about that. It's a really research level problem. We can say that somewhat. And another thing is, extreme thing is a research level difficult problem. Another thing is, it is just pre-calculus mathematics. The questions are based on mathematics of up to 12th standard in which calculus is not required. Even if you solve by calculus, you may get credit, but the problem of frame is such a manner that without calculus, the student will be able to answer. Student પોતાની જાતે જવાબ આપી શકે calculus ના કલન શાસ્ત્ર ભણ્યા વગર. એ પણ છે. Day 1 4.5 કલાક 3 ક્વેશ્ચન, Day 2 4.5 કલાક 3 ક્વેશ્ચન, દરેક ક્વેશ્ચનના 7 પોઈન્ટ્સ, 42 પોઈન્ટમાંથી આપણે એમાં માર્ક્સ નક્કી થાય. અને માર્ક્સમાં કટ ઓફ કઈ રીતે હોય છે? આખા વર્લ્ડના બધા જે પાર્ટિસિપન્ટ હોય અરાઉન્ડ 100 ટીમ્સ ભાગ લે છે. 100 into 6 ગણીએ તો અરાઉન્ડ 600 સ્ટુડન્ટ્સ આર પાર્ટિસિપેટિંગ. એ બધાના 42 માંથી માર્ક્સ કરે છે અને દે give the medal in such a manner that the ratio of the medal is 1 gold, silver and bronze is 1:2:3. For example, 600 students hoy so only not more than 50% can get the medal. So if we assume that 300 participants will be getting medal, and in 300 participants, 50 students will be getting gold, 100 students will be getting silver, and 150 students will be getting bronze. So this kind of medal distribution is there. On the other end, what about the remaining 300? Those who are not getting in the gold in the medal category, they also won incentive. Suppose there are out of 6 questions, you have solved 1 question completely and get 7 full marks. Then you will be getting a honorable mention certificate. That this so and so student has got solved 1 question completely. So that is also one achievement. Not only that, some of the reputed institute, they directly allow to get the admission in that after 12th. CMI, IMSC, you just check the website. There are various IITs, some consider that if you are in a IMO team, an Indian team, then you are getting directly admission in IIT. No need to appear for JAM, JEE, etc. Right? That's a plus point. One more incentive, one can say that. Gujarat, every year usually 1 or 2 students have been selected in top 30 to go for training at Chennai or Mumbai. But after that, very difficult to get the seat in top 6. It's slightly difficult, but still we are trying our best, and I hope that coming generation we can get at least 1 or 2 students from Gujarat. So let us discuss the now problems. What kind of problems usually asked? Is the screen visible, sir?
Yes, sir.
Okay. Fine. Let us take one problem of algebra. Find all real solutions of the system of equations. 4x square upon 1 plus 4x square equal to y, comma 4y square upon 1 plus 4y square equal to z, comma 4z square upon 1 plus 4z square equal to x. It's a problem of algebra. Usually in Olympiad, there are 4 major branches of mathematics are involved. Algebra, combinatorics, geometry, and number theory. Algebra means roots of a polynomial equations, etc. Irreducibility of polynomials, roots of polynomial equations, factorization, something like that. So here we need to solve this system of 3 equations, not linear. That's a problem. Linear one can very easily crack through method of determinant or matrices or Cramer's method. But this is something non-linear because 4x square is involved somewhere. Do you want some time to solve or shall I go ahead, sir? Excuse
Sir,
me.
We can proceed.
Okay, fine. So first let us discuss the only problem, then solution we'll discuss later on. It's a nice problem involving number theory and combinatorics. For each number in the set n plus 1, n plus 2, etc. to n, consider its largest odd divisor and add all such largest odd divisor. Prove that the sum so obtained is n square. Very interesting result. n plus 1, n plus 2, 2n માંથી મોટામાં મોટો અયુગ્મ વિભાજક શોધવાનો છે. ભાજક ધારો કે n તમારો 10 હોય તો 10 નો મોટા મોટો અયુગ્મ કોણ હોય તો 5 એનો ફેક્ટર. ધારો કે 9 હોય 9 નો મોટા મોટો અવિભાજ્ય અવયવ 5 9 થાય. એટલે આ બધા સરવાળો કરો તો n સ્ક્વેર થાય એમ. where n is a natural number, of course. ત્રીજો બી નંબર 3 નો પ્રોબ્લેમ છે કે દરેક ધન પૂર્ણાંક અયુગ્મ ધન પૂર્ણાંક n માટે n raised to 12 minus n raised to 8 minus n raised to 4 plus 1 is divisible by 2 raised to 9. So 2 raised to 9 is the factor of this number. 2 raised to 9 is a very big number, 512 perhaps. Yes. So without checking the value, is it possible to prove that this is always true? Very interesting. Next problem. Suppose px is a polynomial like this. px એક બહુપદી છે x minus a, x minus b, x minus c, x minus d. અને px બરાબર 0 ના 4 ભિન્ન પૂર્ણાંક બીજો છે. Distinct integral roots. અને px equal to 4 ને એક integral root છે k. તો k abcd નો એવરેજ છે, mean, arithmetic mean. k equal to a plus b plus c plus d by 4. ચોથો પ્રોબ્લેમ. પાંચમો, find all pairs of integers x, y such that x cube equal to y cube plus 2y square plus 1. એટલે એવા પૂર્ણાંક x y શોધો કે આ સમીકરણનું સમાધાન કરે. જનરલી 12th માં મેથમેટિક્સ આવું દેખાતું નથી ક્યાંય, કારણ કે આપણે બહુ ક્વોડ્રેટિક ઇક્વેશન જ કહેવાયેલા છે, 1 વેરિયેબલ, એક જ ચલના. પણ આમાં થોડુંક નંબર થિયરી અને થોડુંક એલ્જીબ્રા બંને ભેગું કરીએ તો આનો સોલ્યુશન આવી શકે. ફોર બાય ફોર નું એક એરે લઈએ, 16 નંબર્સ, મેજિક સ્ક્વેર. સમ ઓફ ધ નંબર્સ ઇન each row, each column and each diagonal is 1. Find the sum of the numbers in the four corners of the array. એટલે ખૂણાના 4 નંબરનો સરવાળો કેટલો થશે? દરેક હારનો સરવાળો 4 છે, દરેક સ્તંભનો સરવાળો 4 છે, બે વિકર્ણોનો સરવાળો 4 છે, દરેક વિકર્ણ. તો છેલ્લા ખૂણામાં આવેલા 4 એલિમેન્ટનો સરવાળો કેટલો? આમાં નંબર થિયરી છે કે કોમ્બિનેટરીઝ છે કે એલ્જીબ્રા અત્યારે ખબર નથી પડતી. બીજો એક સેટ લીધો નેગેટિવ, ફર્સ્ટ n નેગેટિવ નેચરલ નંબર્સ, -1, -2, -3 એટસેટ્રા -n. હવે એનો કોઈ પણ નોન નેગેટિવ સબસેટ લો, પછી એ સબસેટના બધા એલિમેન્ટ્સનો પ્રોડક્ટ કરો. દરેક સબસેટનો આવો પ્રોડક્ટ મળે, તે બધા જ પ્રોડક્ટનો સમ કરો તો શું આવશે? બહુ ઇન્ટરેસ્ટિંગ કહેવાય, કારણ કે કેટલા બધા સબસેટ મળે. n એલિમેન્ટ્સ વાળા સેટના સબસેટ એટલે 2n, પણ નોન નેગેટિવ એટલે 2n-1. આવા 2n-1 સબસેટ લેવાના, દરેક સબસેટના બધા એલિમેન્ટ્સનો પ્રોડક્ટ કરો, મલ્ટીપ્લિકેશન કરો, એ જે જવાબ આવે એ બધા જવાબનો સરવાળો કરો, તો એ જવાબ શું આવશે? એટલે આમાં નંબર થિયરી કે એલ્જીબ્રા ખબર નથી પડતી. અત્યારે શરૂઆતમાં સોલ્વ કરતા પહેલા વિચારવું પડે. અને આરએમઓ આઈઓક્યુનો પ્રોબ્લેમ તરત સોલ્વ નહીં કરવાનો. સ્કૂલમાં શું છે, આપણે ટેક્સ્ટ બુક જોઈને દડ કરવા મળી ગયા આવી જશે. 5 મિનિટ તો બરાબર વિચારવાનું કે આમાં શું, કયા રસ્તે જઈએ તો સારું. એટલે અમારે તમારી થિંકિંગ પ્રોસેસ ડેવલપ થાય છે. You will be original in the subject if you are trying to attacking this kind of problems. પોલિનોમિયલ છે એટલે એલ્જીબ્રા છે, પણ એકલું એલ્જીબ્રા નંબર થિયરી પણ છે. પીએક્સ એક પોલિનોમિયલ છે, બહુપદી, જેના સહગુણકો ઇન્ટીજર્સ છે. એનો લીડિંગ કોએફિશિયન્ટ એટલે x ની મહત્તમ ઘાત વાળો અચળ પદ, અને p1 આ ત્રણ ઓડ છે. તો px ને કોઈ પણ રેશનલ રૂટ નથી. સમય સંખ્યા એનું બીજ નથી, એ બતાવવાનું છે. આ બહુ ઇન્ટરેસ્ટિંગ પ્રોબ્લેમ છે કે તમારી પાસે a1 × a નંબર 1 અને -1 માંથી જ લેવાના છે. અને એ રીતે લેવાના છે કે a1 + a2 + a3 + a1 × a2 × a3 × a4 આ 4 નો ગુણાકાર, પછી બીજા 4 નો ગુણાકાર જેમાં a2 થી શરૂઆત થાય, ત્રીજા જેમાં a3 થી શરૂઆત, છેલ્લા જે an થી શરૂ થાય, એ બધાનો સરવાળો 0 થાય. તો તમારો n કેવો હશે? એ 4 વડે વિભાજ્ય જ હશે. તમે ગમે તે 1 - 1 લો, પણ હંમેશા કરશો આ રીતે કરો એવું થાય તો તમારો n 4 વડે વિભાજ્ય હશે. બસ ટિકિટ, અત્યારે બસ કે મેટ્રો કે BRTS ટિકિટ કહીએ તો ચાલે. 6 ડિજિટ એક નંબર આપેલો છે બસમાં. એ નંબરને આપણે લકી નંબર કહીશું કે સમ ઓફ ઇટ્સ ફર્સ્ટ ડિજિટ ઇઝ ઇક્વલ ટુ ધ સમ ઓફ લાસ્ટ 3 ડિજિટ. ફોર એક્ઝામ્પલ 1 2 3 6 0 0. ઓકે, 1 2 3 નો સમ 6 અને 6 0 0 નો સમ 6, એટલે બંને સરખા થયા. પહેલા 3 નો સમ અને બીજા 3 નો, તો એ નંબરને લકી નંબર કહેવાય. તો કે prove that the number of lucky tickets equals the number of tickets with the sum of all the digits equal to 27. એટલે એવી ટિકિટ કે જેના 6 સંખ્યાનો સરવાળો 27 થાય, એ એવી ટિકિટોની સંખ્યા અને આ લકી ટિકિટની સંખ્યા બંને સરખી થાય. ઇન્ટરેસ્ટિંગ. એ તો શોધવું, વિચાર માંગી. એટલે 10 પ્રોબ્લેમની આપણે ચર્ચા કરીએ. So shall we go to the first problem? First problem કયો હતો? ફર્સ્ટ પ્રોબ્લેમ હતો ઇક્વેશન્સ વાળો. 3 ઇક્વેશન સોલ્વ કરવાનું. જો સોલ્વ ઇન આર. ત્રણેય ઇક્વેશનમાં એક સરખાપણું જોવા મળે. જો ફર્સ્ટ ઇક્વેશનમાં x ની જગ્યાએ y મૂકીએ અને y ની જગ્યાએ z, if you replace x by y and y by z, then you will be getting second equation. Same thing in second equation, if you replace y by z, z by x, you will be getting the third equation. Same thing in third equation, if you replace z by x and x by y, you will be getting first equation. So this kind of call, it is called cyclic symmetry. वर्तुळમાં તમે x y z क्रमशः લખો सर्कल पे, तो आपको मिलेगा कि x is replaced by y is replaced by z is replaced by x. There is no change in the system except the order of the equations. It is called cyclic symmetry. So cyclic symmetry no advantage લેતા આવડવું જોઈએ. First you need to observe that it is cyclic symmetry, and the second, how to take the advantage of cyclic symmetry. ચક્રીય સંમિતતા ગુજરાતીમાં કહીએ તો જો ફર્સ્ટ ઇક્વેશનમાં y છે, y equal to 4x square upon 1 plus 4x square. તો બે જગ્યાએ x square છે, એમાં એક જ જગ્યાએ લાવું તો બંને ઉપર નીચે ડિવાઇડ ન્યુમરેટર ડિનોટ બાય 4x square, તો આપણને આવું મળે. So by symmetry z આવું મળે and x આવું મળે. હવે xy z તો greater than equal to 0. શા માટે? Because y is equal to 4x square upon 1 plus 4x square. Square is always non-negative, so 4x square is non-negative. 1 plus 4x square is positive. Non-negative upon positive is non-negative, so y is non-negative. By the same argument, z is also non-negative, x is also non-negative. ત્રણ નેગેટિવ છે તો આપણે વિધાઉટ લોસ ઓફ જનરાલિટી આપણે એઝ્યુમ કરી શકીએ, ધારી શકીએ કે x લેસ ધેન ઇક્વલ ટુ y લેસ ધેન ઇક્વલ ટુ z. જો y લેસ ધેન ઇક્વલ ટુ z લેસ ધેન ઇક્વલ ટુ x કરો તો બી જવાબ તો હશે જ એ રીતે. ક્લિયર? આપણે y ઇક્વલ ટુ 1 upon 1 plus 4x square plus 1 લાય, એમાં જો y એક જ જગ્યાએ છે ને x square બી એક જ જગ્યાએ છે. That's an advantage. So what is the advantage? That is, this is the advantage. X less than equal to y less than equal to z હોય તો x બરાબર શું હતું? જો આગળના ઇક્વેશનમાં 1 upon 1 whole upon 1 upon 4z square plus 1. એટલે 1 upon this will be 4z, 1 upon 1 4z square plus 1 less than or equal to, એ રીતે y વાળું ટર્મ્સ અને એ રીતે z વાળું ટર્મ્સ. Taking reciprocal of each, so inequality will be changed, order will be changed. Subtract 1 from each, so we are getting 1 upon 4z square greater than equal to 1 upon 4x square greater than equal to 1 upon 4y square. એટલે કે again taking reciprocal, તો inequality will change, z square less than equal to x square less than equal to y square. Since z x y are non-negative, so taking non-negative under root, z less than equal to x less than equal to y. So remember, we assume that x less than equal to y less than equal to z, and we arrived at z less than equal to x less than equal to y. That means if you combine both these inequalities, આ બંને inequality ભેગી કરીએ તો x equal to y equal to z થાય. તો પછી એક જ ઇક્વેશનમાં જે છે પહેલું ઇક્વેશનમાં x equal to y લખી કાઢો તો આપણને આવું મળશે, x equal to 4x square upon 1 plus 4x square. वन प्लस 4x स्क्वायर તમે લેફ્ટ હેન્ડ સાઈડ લઈ જાઓ તો x into 1 plus 4x square equal to 4x square. એક એક કેન્સલ કરો, પણ એ કેન્સલ કરતા પહેલા x 0 નથી, એટલે જો 0 હોય તો એક સોલ્યુશન વિચારો, ન હોય તો કેન્સલ કરો. તો 1 plus 4x square equal to 4x. અને એને સોલ્વ કરો કે ઇટ ઇઝ ક્વોડ્રેટિક ઇક્વેશન, વેરી સિમ્પલ. 2x minus 1 whole square equal to 0 થશે. So we are getting x equal to 0 or x equal to half. એટલે એક સોલ્યુશન મળ્યું 0 0 0 અને બીજું સોલ્યુશન મળ્યું half half half. What is the heart of this problem? Let us come back to the original problem. Cyclic symmetry. સાયક્લિક સિમેટ્રી સ્કૂલમાં ક્યાં એવું ભણાવવાતું નથી કે આ સાયક્લિક સિમેટ્રી, પણ આપણે હવે આંખોથી ખબર પડી ગઈ, ઓબ્ઝર્વેશન. You should be able to visualize, oh, something is there. This is cyclic symmetry. And પછી order property. If we assume that x is equal to y is equal to z, we are getting z less than or equal to x square. એટલે ત્રણ equal થઈ ગયા એટલે put substitute this in one of the equation, you will be getting simply a cubic equation in which you can solve very easily, right? So this is the answer. એટલે આવા પ્રોબ્લેમ ઘણા બધા છે આવા કે જેમાં સાયક્લિક સિમેટ્રી ઇન્વોલ્વ હોય, ઓર્ડર સ્ટ્રક્ચર ઇન્વોલ્વ હોય, orders of real number, properties of orders, and cyclic symmetry in 3 variables, of course real variables. Second problem. For each number in the set n plus 1, n plus 2, etc. to n, consider its largest odd divisor and add all such largest odd divisor. Prove that the sum so obtained is n square. मैं पहले મને ખબર નથી મેં શું પૂછ્યું હતું પહેલા. What is the second problem? Let me recollect. हाँ, n square, right. કેવી રીતે કરવું આ? સૂઝે જ નહીં. એટલે જે સમ છે દરેક એલિમેન્ટ આ સેટનો જે એલિમેન્ટ છે એનો લાર્જેસ્ટ ઓડ ડિવાઇઝર ભેગો કરો, એ બધાનો એડ કરો. લેટ અસ કોલ ધીસ એઝ fn, and dn is the largest odd divisor of n. So d5 is 5, d4 is 1, કારણ કે 4 નો લાર્જેસ્ટ ઓડ ડિવાઇઝર 1 થાય, d10 is 5, something like that. The fn શું થશે? sigma di I varies from n plus 1 to 2n. હવે આપણે fn plus 1 કેલ્ક્યુલેટ કરવું છે. We will obtain some recurrence relation between fn and fn plus 1. fn plus 1 તો આખો સેટ બદલી જશે. જેમ કે fn નો સેટનો પહેલો એલિમેન્ટ કયો છે n plus 1 અને લાસ્ટ એલિમેન્ટ કયો છે 2n. તો fn plus 1 થોડું બદલાશે. પહેલો એલિમેન્ટ થશે n plus 2 અને લાસ્ટ એલિમેન્ટ થશે 2 ટાઈમ્સ બ્રેકેટમાં n plus 1. એટલે fn plus 1 is sigma di I varies from n plus 2 to 2 times n plus 1. બારે fn plus 1 ને fn જોડે સાંકળવું છે. તો fn ની ફોર્મ્યુલા આ છે, sigma di I varies from n plus 1 to 2n. એટલે આ જે fn plus 1 નો સિગ્મા છે એમાં કઈ ટર્મ મિસિંગ છે અને કઈ ટર્મ વધારાની છે? કઈ ટર્મ મિસિંગ છે? dn plus 1 is missing. So if you add dn plus 1 and subtract dn plus 1, કઈ ટર્મ વધારે છે? d2n plus 1 and d2n plus 2. બે ટર્મ્સ એક્સ્ટ્રા આવી, એ બે વધારાની છૂટી પાડી. એટલે નવો સમેશન થયો સિગ્મા di I varies from n plus 1 to n di બ્રેકેટ ઓવર, અને પેલી જે ટર્મ ખૂટતી હતી એને બાદ, જે ઉમેરી એને બાદ કરી, અને જે વધારે નથી એને પ્લસ વાળી લખી. એટલે કે માઇનસ dn plus 1 plus d2n plus 1 plus d2n plus 2, રાઈટ? હવે d2n plus 1 નો મીનિંગ કાઢીએ. d2n plus 1 એટલે d2 into bracket n plus 1. 2 into bracket n plus 1 એ ઇવન નંબર થાય. એનો લાર્જેસ્ટ ઓડ ડિવાઇઝર એ n plus 1 ના ઓડ ડિવાઇઝર જેટલો થાય. એગ્રી? ફરી પોઈન્ટ સમજો. 20 છે, 20 નો લાર્જેસ્ટ ઓડ ડિવાઇઝર એ 10 નો લાર્જેસ્ટ ઓડ ડિવાઇઝર કહેવાય કે નહીં? 20 નો લાર્જેસ્ટ ઓડ ડિવાઇઝર કયો છે? 5. 10 નો લાર્જેસ્ટ ઓડ ડિવાઇઝર કયો છે? 5. એટલે કે d20 equal to d10. એટલે બેકી સંખ્યા માટે આવું થશે, d20 equal to d10, d12 equal to d6. એટલે એ લોજિક પ્રમાણે d2 into n plus 1 equal to dn plus 1. નેક્સ્ટ 2n plus 1 તો ઇવન છે, તો જો નંબર પોતે ઇવન હોય તો લાર્જેસ્ટ ઓડ ડિવાઇઝર એ પોતે જ થાય 2n plus 1. મોટામાં મોટો અયુગ્મ અવયવ. એટલે d2n plus 1 હંમેશા 2n plus 1 થાય. એટલે જે ત્રણ ટર્મ છે એમાં બે ટર્મની વેલ્યુ તો મળી ગઈ. એટલે માઇનસ dn plus 1 અને પ્લસ d2n plus 1, જેની જગ્યાએ હવે dn plus 1 લખી શકીએ એટલે કેન્સલ થઈ જાય, અને d2n plus 1 એટલે 2n plus 1. એટલે આમાં આપણને મળે fn plus 1 equal to fn પ્લસ 2n પ્લસ 1 એટલે કે fk પ્લસ 1 માઇનસ fk બરાબર 2k પ્લસ 1 ફોર each k belongs to 1 to n minus 1. અને તમે k બરાબર n minus 1 લખો તો fn minus fn minus 1 બરાબર કંઈક મળે. k બરાબર n minus 2 લખો તો fn minus 1 minus fn minus 2 બરાબર કંઈક મળે, વગેરે વગેરે મળતા જાય. એ બધાનો સરવાળો કરીએ તો જમણી બાજુ fn minus f1 રહે, ડાબી બાજુ સોરી લેફ્ટ હેન્ડ સાઈડ, અને રાઈટ હેન્ડ સાઈડ બધાનો સમય થાય. પણ હમણાં આપણે બતાવ્યું કે fk પ્લસ 1 માઇનસ fk બરાબર તો 2k છે. તે 2k પ્લસ 1 છે તો 2k પ્લસ 1 મૂકી દો, અને આ તો સમ ઓફ ધ ફર્સ્ટ ઓડ નેચરલ નંબર્સ, n ઓડ નેચરલ નંબર્સ, અને એ ફોર્મ્યુલા આપણને ખબર છે કે ઇટ ઇઝ n સ્ક્વેર. સો fn ઇઝ n સ્ક્વેર. Agree? This is a very problem based on number theory as well as combinatorics. Algebra તો આવ્યું જ નથી આમાં, એમ કહીએ તો ચાલે. થર્ડ પ્રોબ્લેમ લઈએ. Prove that for every odd integer n raised to 12 minus n raised to 8 minus n raised to 4 plus 1 is divisible by 2 raised to 9. સિમ્પલ ફેક્ટર પડે, જો બરાબર ધ્યાનથી જુઓ. n raised to 12 minus n raised to 8 minus n raised to 4 plus 1 can be factorized in this manner. n raised to 8 minus 1 in one bracket, second bracket n raised to 4 minus 1. Again n raised to 8 minus 1 can be further factorized, n raised to 4 minus 1 into bracket n raised to 4 plus 1. Again n raised to 4 minus 1 can be further factorized, n minus n square minus 1 n square plus 1. અને સ્ક્વેર છે એટલે આવું કરવું પડે. તમારો n ઓડ છે, n ઓડ છે તો n રેસ ટુ 4 e ઓડ થશે, એમાં એક ઉમેરેલે e1 થશે. જે છેલ્લો બ્રેકેટ છે n રેસ ટુ 4 પ્લસ 1 એમાંથી બે ફેક્ટર મળવાનો. એ જ રીતે n સ્ક્વેર પ્લસ 1 પણ e1 થવાનું. એનો સ્ક્વેર છે એટલે એમાંથી કુલ 4 ફેક્ટર મળશે, એટલે 4 into 2 8 થઈ ગયા. હવે n સ્ક્વેર માઇનસ 1 ઉપર આવીએ. n સ્ક્વેર માઇનસ 1 ની વિશેષતા છે કે n ઓડ છે તો n સ્ક્વેર માઇનસ 1 એ 8 થી વિભાજ્ય થાય. ઇટ ઇઝ ડિવિઝિબલ બાય 8. કેવી રીતે? ઇન્ટરેસ્ટિંગ ક્વેશ્ચન. કે n સ્ક્વેર માઇનસ 1 ના આગળ ફેક્ટર પાડી દે કે n માઇનસ 1 ને એક n પ્લસ 1. n ઓડ છે એટલે n માઇનસ 1 e1, n પ્લસ 1 પણ e1, એટલે બંનેમાંથી બે બે નીકળશે, પણ આ તો કે 8 નીકળે એટલે 2 3 વખત નીકળે. કેવી રીતે ખબર પડે? કોઈ આઈડિયા? આમાં સ્ટુડન્ટ્સને સ્ટુડન્ટ બી જવાબ આપી શકે, રિસ્પોન્સ આપે એવું કરો તો સારું. એમ છોકરો કોઈ મને ખબર પડે કે એની ડિફિકલ્ટી ક્યાં છે. ઓકે, શક્ય હોય તો પ્લીઝ. એ ઇમ્પોર્ટન્ટ છે. n માઇનસ 1 ને n પ્લસ 1 બંનેનો ડિફરન્સ ટ્રુ છે અને બંને ઇવન ઓડ છે, બંને ઇવન છે એટલે બે કોન્ઝ્યુગેટિવ ઇવન થયા. તો બે કોન્ઝ્યુગેટિવ, ધારો કે 2 અને 4, તો એનો ગુણાકાર 8 થાય. 4 અને 6 24, 24 માં 8 ફેક્ટર છે. 6 અને 8 48 એમાં 8 ફેક્ટર છે. એટલે બે કોન્ઝ્યુગેટિવ ઇવન નો પ્રોડક્ટમાં ઓલવેઝ 8 ફેક્ટર આવે જ. બરાબર? આ એક રીત છે. બીજી રીત હું નોટપેડમાં બતાવું. n સ્ક્વેર માઇનસ 1 એમાં મારે બતાવવું છે કે 8 ડિવાઇડ્સ n સ્ક્વેર માઇનસ 1 ફોર ઓડ n. ઓડ n છે તો n ઇક્વલ ટુ 2k પ્લસ 1 લખી શકાય, 2k માઇનસ 1 લખી શકાય. યસ. તો હવે n સ્ક્વેર માઇનસ 1 માં આ મૂકી દઈએ. ટુ કે માઇનસ 1 સ્ક્વેર માઇનસ 1 ઇક્વલ ટુ 4k સ્ક્વેર. આ બીજી મેથડ છે, પેલા કરતા અલગ, હટકે. માઇનસ 4k પ્લસ 1 માઇનસ 1, એટલે 1 ને માઇનસ 1 જતા રહે, એટલે 4k સ્ક્વેર માઇનસ 4k. એટલે કે 4 કોમન, k કોમન, k માઇનસ 1, એટલે 4 તો ફેક્ટર દેખાય છે, 4 ઇન્ટુ સમથિંગ લખ્યું છે એટલે. હવે k ઇન્ટુ k માઇનસ 1 એ બે કન્ઝ્યુગેટિવ છે, ક્રમિક સંખ્યાઓ થઈ, k અને k માઇનસ 1, k માઇનસ 1 નાની અને k મોટી. તો બે કન્ઝ્યુગેટિવ નંબર્સ હોય તો એનો પ્રોડક્ટ હંમેશા ઇવન થાય, કારણ કે એક એકી હોય ને એક બેકી હોય. વન ઓફ ધેમ ઇઝ ઓડ, ધેન અધર ઇઝ વિલ બી ઇવન. જો k ઓડ હોય તો k માઇનસ 1 ઇવન, અને જો k માઇનસ 1 ઓડ હોય તો k ઇઝ ઇવન. એટલે ટૂંકમાં 2 ફેક્ટર નીકળે છે. તો આપણે લખી શકાય કે ઇઝ ડિવિઝિબલ બાય 8. આ સેકન્ડ પ્રૂફ. બરાબર. કોંગ્રુઅન્સ થી બી આપી શકાય છે, પણ આપણે કોંગ્રુઅન્સ નથી બદલેલા. એલિગન્ટ સોલ્યુશન કોને કહેવાય? એલિગન્ટ સોલ્યુશન એટલે વોટ ઇઝ બાય એલિગન્ટ સોલ્યુશન? કોઈને તલવારથી મારો એના કરતા પિનથી મારો સારો. એટલે ઓછી વસ્તુનો ઉપયોગ કરીને તમે એનું સોલ્યુશન લાવો તેને એલિગન્ટ સોલ્યુશન કહેવાય. એટલે આપણે કોંગ્રુઅન્સ જેવો વાઈફાઈ મેથડ લાવતા નથી, સાદા ફેક્ટર્સ અને ઓડ ઇવન એના પરથી આપણે પ્રૂવ કર્યું. બરાબર. એટલે 8 એમાંથી ફેક્ટર મળ્યો અને એનો સ્ક્વેર છે એટલે 64 થાય, એટલે 2⁶ થાય. n સ્ક્વેર પ્લસ 1 માં બી 2 નીકળે, એનો સ્ક્વેર છે એટલે 2⁵2 થાય. 2⁶ 2⁵2 એટલે 2�8, અને n⁴ પ્લસ 1 માંથી બી 2 નીકળે છે, એટલે કુલ 2⁹ નીકળે છે. રિયલી આ IOQM લેવલનો પ્રોબ્લેમ કહી શકાય, RMO લેવલનો ના કહેવાય. હવે આ જુઓ, px be the polynomial x minus a, x minus b, x minus c, x minus d. અને px બરાબર 0 4 ડિસ્ટિંક્ટ ઇન્ટિગ્રલ રૂટ્સ છે. અને px બરાબર 4 નું એક ઇન્ટિગ્રલ બીજ k છે. તો k is the mean of ABCD. કેવી રીતે વિચારીશું કે આ પોલિનોમિયલ એવરેજ તો આપણે px બરાબર 0 ના બીજ ધારી લઈએ ABCD. અહીંયા કોમા મેસિંગ છે, ધ્યાન રાખજો. અને તે ઇન્ટીજર છે એટલે બિલોંગ્સ ટુ z. each of this belongs to z. We may assume that a less than or equal to b less than or equal to c less than or equal to d. પછી px બરાબર 4 નું એક બીજ છે k, એટલે કે k minus a into k minus b into k minus c into k minus d equal to 4. હવે a less than or equal to b less than or c less than or d હોવાથી ચારે બાજુ માઇનસ થી મલ્ટીપ્લાય કરીએ અને k ઉમેરીએ આવું થાય. k minus d less than or equal to k minus c less than or equal to k minus d less than or equal to k minus a. હવે એ ચારેનું મલ્ટીપ્લિકેશન તો 4 છે. k માઇનસ a ઇન્ટીજર છે, k માઇનસ b ઇન્ટીજર છે, k માઇનસ c ઇન્ટીજર છે અને k માઇનસ d ઇન્ટીજર છે. તો ચાર ઇન્ટીજરનો પ્રોડક્ટ 4 કઈ રીતે થાય? એમાં કોઈ બે સરખા નથી. જો a અને b ડિસ્ટિંક્ટ હોય, હા ડિસ્ટિંક્ટ લખેલું છે એટલે આપણે લેસ ધેન ઓર ઇક્વલ ટુ બી નહીં, સ્ટ્રિક્ટલી લેસ ધેન લખવું જોઈએ. આ કરેક્શન છે મારા તરફથી. આ ઓફિશિયલ જે સોલ્યુશન છે એમાં થોડું કરેક્શન કરીએ. એટલે k માઇનસ a અને k માઇનસ b સરખા ના થાય, કારણ કે જો સરખા થાય તો a બરાબર b થઈ જાય. એ તો આપેલું છે કે ડિસ્ટિંક્ટ છે. એટલે 4 ના 4 ફેક્ટર્સ પાડો કે ચારે 4 ફેક્ટર ડિસ્ટિંક્ટ હોય. 4 ના તો 3 જ ફેક્ટર છે પોઝિટિવ, 1 2 4. નેગેટિવ બી 3 છે, -1 -2 -4. બરાબર. 4 ના 4 પોઝિટિવ ફેક્ટર નથી, 3 જ છે. 1 2 4. નેગેટિવ બી 3 જ છે. એટલે જમણી બાજુ 4 પોઝિટિવ ફેક્ટર આવે એવું બને નહીં. બાય ધ સેમ લોજિક 4 નેગેટિવ ફેક્ટર આવે એવું બને નહીં. એનો અર્થ કે અમુક પોઝિટિવ ને અમુક નેગેટિવ હોય. એક જ પોઝિટિવ ને 3 નેગેટિવ એવું બને નહીં, કારણ કે આનો પ્રોડક્ટ નેગેટિવ થાય અને આપણે 4 આપેલું, 4 ઇઝ પોઝિટિવ. એક જ નેગેટિવ ને 3 પોઝિટિવ એમાં બી પ્રોડક્ટ નેગેટિવ થાય, એ પણ ના ચાલે. એનો અર્થ શું થયો? તમારે 2 નેગેટિવ લેવા પડશે, 2 પોઝિટિવ લેવા પડશે. અમારે કોઈ ફેક્ટર 4 ના લઈ શકાય, કારણ કે એક ફેક્ટર 4 લો તો તમારે 2 1 અને -1 તો પછી 2 લેવા પડે. 4 2 તો 8 થઈ જાય. 4 2 8. 4 ને પ્રોડક્ટ 4 થાય છે, એટલે 4 નહીં લેવાય. એનો અર્થ કે આ 4 જ ફેક્ટર થશે. કયા? -2 -1 1 અને 2. એટલે કે તમારા જે 4 ફેક્ટર છે એ 4 ફેક્ટરનો પ્રોડક્ટ આ જ છે, બીજી કોઈ રીતે લખાતો નથી. એટલે કે K - A જમણી બાજુના 4 માંથી કોઈ એક નંબર હશે. એ જ રીતે K - B એ નંબર લીધા છે પછીનો નંબર હશે એક. ટૂંકમાં એ 4 નો સરવાળો કરો તો આ 4 ફેક્ટરનો સરવાળો જ કરવો પડે. -2 -1 1 અને 2 આ 4 નો સરવાળો કરો તો 0 આવે છે. એનો અર્થ એમ થયો કે 4K બરાબર A પ્લસ B પ્લસ C પ્લસ D. એનો અર્થ કે K બરાબર A પ્લસ B પ્લસ C પ્લસ D બાય 4. રાઈટ? The K is the arithmetic mean of these 4 numbers. આવો કોઈ પ્રોબ્લેમ વિચારી શકાય જેમાં K is a geometric mean of ABC? વિચારજો તમે, આવું કંઈક મળે? અથવા 3 નંબરનો ABC નો. રાઈટ? થિંક અબાઉટ ધીસ. ઓલિમ્પિયાડની એક વાત કહું. હું છેલ્લે કોરોના પહેલા ગયો તો ટ્રેનિંગમાં, ઓલિમ્પિયાડ ટ્રેનિંગમાં 2016માં હોંગકોંગ ગયો હતો. ત્યારે એક વિદ્યાર્થી હતો અનંત મુદગલ. એ અનંત મુદગલ અમારા ટીમનો મેમ્બર હતો. બહુ ધૂની માણસ, થોડો ભૂલકણો. ઇન્ડિયન ટીમનું બ્લેઝર આપ્યું તો બ્લેઝર ક્યાંક એરપોર્ટ પર ભૂલી ગયો. આવું છું. એને બ્રોન્ઝ મેડલ આવ્યો એ વખતે. પછી તમે નહીં માનો, 2016 પછી આશ્ચર્ય થશે, 2016 પછી જેને અમારી જેમ ફેકલ્ટી નથી કરી લીધો. તું પહેલા વર્ષે આવે, જો બધી એક્ટિવિટી, બીજા વર્ષે તને ફેકલ્ટી એમ એટલે ટ્રેનિંગ માટે. અને આજે 25 24 આજે 23 22 કે 21માં એનો IMO એક પ્રોબ્લેમ સિલેક્ટ થયો હતો. IMO પ્રોબ્લેમ કઈ રીતે સિલેક્ટ થાય એ બી એક મોટો હિસ્ટ્રી છે. તમે પ્રોબ્લેમ સોલ્વ કરો એ તો ગ્રેટ હિસ્ટ્રી, પણ તમારો પ્રોબ્લેમ ત્યાં સિલેક્ટ થાય એ તો વધારે અચીવમેન્ટ કહેવાય. ઇન્ડિયાના બહુ ઓછા ગણે ગાંઠે ગણિત શાસ્ત્રીઓ કે જેના પ્રોબ્લેમ ત્યાં સિલેક્ટ થયા છે. જે 6 ની જે કોમ્પિટિશનમાં 6 એ આખી પ્રક્રિયા બહુ વિચારવા જેવી છે ઇન્ટરનેશનલ લેવલે. એમાં શું હોય છે, આ જે ટીમ જાય ઇન્ડિયાની ટીમ, એ જે ઇન્ડિયાની ટીમ જાય છે, હું મારી વાત કરું, 2016માં ગયો. તો લગભગ અમારે 8 થી 10 દિવસનું પેકેજ હોય જવાનું છે. હોંગકોંગ ગયા હતા. મારી પહેલા આપણી ઇન્ડિયાની ટીમનો લીડર જાય. ઇન્ડિયાની ટીમ લીડર હતા ડોક્ટર પૃથ્વીજીત ડે, જે અત્યારે આપણા નેશનલ ઓલિમ્પિયાડ કોઓર્ડિનેટર છે. એ હતા કે ઓબ્ઝર્વર હતા, એમની બે કેટેગરી હતી, બેમાંની એક હતી. તો એ લોકો દરેક દેશના લીડર આગળ ભેગા થાય 2 દિવસ પહેલા પરીક્ષાનું પેપર સેટ કરવા માટે. એ પહેલા ધારો કે હું ઇન્ડિયામાં અહીંયા છું, મને લાગે કે મેં એક નવો પ્રોબ્લેમ બનાવ્યો, તો એ પ્રોબ્લેમ હું આગળ મોકલું, આગળ ઇન્ટરનેશનલ લેવલે મોકલું. એટલે ઇન્ટરનેશનલ લેવલે લગભગ 100 થી 150 પ્રોબ્લેમનું કલેક્શન થાય. પછી અમે જે ટ્રેનિંગ આપીએ છીએ બોમ્બેમાં 4 અઠવાડિયાની, એમાં કયા કયા પ્રોબ્લેમની ચર્ચા થઈ એ પ્રોબ્લેમ લિસ્ટ બી એમની પાસે હોય, માની લો એ લોકો જાણતા હોય કયા કયા પ્રોબ્લેમ ડિસ્કસ કર્યા, કોઈ નવા કર્યા હોય. એટલે ધારો કે ચીન વાળા એક પ્રોબ્લેમ મૂક્યો કે ભાઈ મારે આ પ્રોબ્લેમ છે, પણ લાગે કે ઇન્ડિયામાં પ્રોબ્લેમ ડિસ્કસ થઈ ગયો તો એને બાજુ મૂકી દો. એટલે 150 પ્રોબ્લેમ ગમે તો 150 માંથી મોટા ભાગના આ રીતે બાજુમાં જતા રહે, માંડ થોડા રહે. એ જે દેશમાં આઈએમઓ રમાતી આઈએમઓ હોય એ દેશની યજમાન સંસ્થાની એક પ્રોબ્લેમ કોઓર્ડિનેટર્સ કમિટી હોય, એ લોકો 30 પ્રોબ્લેમ નક્કી કરે. 150 માંથી 50-70 નીકળી જાય, બીજા એમાં 30 નક્કી કે આ 30 આપણે રાખવાના. એ 30 ને કહેવાય શોર્ટ લિસ્ટેડ પ્રોબ્લેમ. એ 30 પ્રોબ્લેમમાં બી આપણું ના આપણા કોઈ પ્રોબ્લેમ નામ આવે તો એવી ગ્રેટ અચીવમેન્ટ કહેવાય. પછી જે 2 દિવસ મીટિંગ થાય, લીડર આગળ જાય, ડેપ્યુટી લીડર વચ્ચે કોઈ સંબંધ ના હોય, એ વખતે ક્યારેય ભેગા ના થાય. એટલે બધા લીડરો ભેગા થઈને 30 પ્રોબ્લેમની ચર્ચા કરે. ત્યાં કોઈ લીડર કહે કે આ પ્રોબ્લેમ બહુ સહેલો છે, કાઢી નાખો. પેલો કે આ પ્રોબ્લેમ બહુ અઘરો છે, કાઢી નાખો. પેલો કે આ પ્રોબ્લેમ અમારે 2 વર્ષ પહેલા ચર્ચા થઈ ગઈ છે, તો કાઢી નાખો. એ કરીને જ 30 રહે ને, 30 ની ઉપર વોટિંગ થાય કયો પ્રોબ્લેમ રાખવો છે, કયો નહીં. અને છેલ્લે 6 પ્રોબ્લેમનું આખો 2 દિવસની એક્ઝામ થાય, 3 આનું ક્વેશ્ચન પેપર સેટ થાય. એટલે કોઓર્ડિનેટર શું કામ, ડેપ્યુટી લીડરનું કામ ક્વેશ્ચન પેપર સેટ કરવામાં એક સહભાગી હોય. અને બીજું, એ 2 દિવસે લીડર જાય, એણે પોતાની સંસ્થાના કોઈની જોડે ફોન ઉપર એ વાત નહીં કરવાની, ઈમેલ નહીં કરવાનું. આ બધું કોન્ફિડેન્શિયલ રખાય. ભૂતકાળમાં એવું કદાચ બન્યું હતું, એવું ભૂતકાળમાં કે કોઈ એક ટીમને બધા જ સારા માર્ક એટલે ચેક કર્યું, ખબર પડી કે આવું કંઈક થયું, તો એ ટીમને બેન કરી દીધેલી થોડાક વર્ષો માટે. એટલે આવું બહુ જ કોન્ફિડેન્શિયલિટી જળવાઈ જાય. હું ડેપ્યુટી એટલે મારી જોડે જે 6 છોકરા હતા એની ટીમને લઈને જાઉં, એટલે હું 6 છોકરાનો મેન્ટર કહેવો. 6 છોકરાની ટીમ, મારી જોડે કોઈ ઓબ્ઝર્વર હોય તો એ પણ આવે. એ લોકો યજમાન સંસ્થામાં 2 દિવસ પછી જાય, ત્યાં પહોંચે, પછી 1-2 દિવસ એક્સકર્ઝન ને બધું હોય, કારણ કે થોડા ફ્રેશ થાય. ત્યાં સુધી હું મારા ડેપ્યુટી લીડરને મળી ના શકું, લીડરને ના મળી શકું. હું ડેપ્યુટી લીડર મારા લીડરનું મળે સંપર્કે ના કરી શકું. ત્યાં સુધી પહેલા દિવસે પરીક્ષા પૂરી થાય પછી, એટલે 2 દિવસ એક્સકર્ઝન ફરવાનું હોય, ઉદઘાટન ને બધું હોય, એ અમુક પ્રોગ્રામ એટેન્ડ કરવાના હોય. 2 દિવસ પછી એક્ઝામ થાય. ધારો કે પહેલા દિવસની એક્ઝામ પૂરી થઈ, પછી જેવી બીજા દિવસની એક્ઝામ શરૂ થઈ એટલે પેપર ઓપન થઈ ગયું. આપણા છોકરાઓ બધા બાળકો વિદ્યાર્થીઓ પેપર આપતા હોય, એક્ઝામ આપતા હોય, પછી લીડર અને ડેપ્યુટી એકબીજા જોડે ભેગા થાય. એટલે પેપર પબ્લિકલી ઓપન થયા પછી જ તમે લીડરનો સંપર્ક કરી શકો. હા, જયારે ઉદઘાટન સમારોહ હોય તો લીડરો ઉપર જે હોલ હોય એના ઉપલા માળે જતા હોય, તમે નીચેના માળે હોય, એટલે તમે એકબીજાને દૂરથી હાય કરી શકો પણ તમે જઈ ના શકો, એટલું રિસ્ટ્રિક્શન હોય. તો આ રીતે પ્રોબ્લેમ જે 6 થયા એમાં આપણા આનંદ મુદ્ગલ નામનો જે છોકરો જે 16માં હતો આપણો વિદ્યાર્થી, અત્યારે તો CMIમાં મેથેમેટિક્સ કરે છે, એ નો પ્રોબ્લેમ સિલેક્ટ થયો જ્યોમેટ્રીનો. તમે વિચારો કે ઓલિમ્પિયાડમાં પહોંચેલો વિદ્યાર્થી બીજા જ વર્ષે કે ત્રીજા વર્ષે ફેકલ્ટી થઈ જાય એ તો ઠીક, પણ ઇન્ટરનેશનલમાં એનો પ્રોબ્લેમ સિલેક્ટ થાય એટલે ગ્રેટ અચીવમેન્ટ કહેવાય ઇન્ડિયાની. એટલે ઇન્ડિયામાં ટેલેન્ટ તો ઘણી છે, ટેલેન્ટ શોધવાનું કામ અઘરું છે. હું અહીંયા બેઠો બેઠો તમને ટોક આપું છું, મારે તમારી ખરેખર જો ઇન્ટરેક્ટિવ સેશન થતું, તમે જો સારી રીતે ઇન્ટરેક્શન કરી તમે ટેલેન્ટ હું બહાર લાવી શકો, અથવા મને ખબર પડે કે આ નામ છે. અને એવા તો ઘણા વિદ્યાર્થીઓ તો ઓલિમ્પિયાડમાં કે જે સળંગ 4 વર્ષ આઈએમમાં બેઠા હોય, 5 વર્ષ બેઠા હોય. અભિષેક ડાંગ, સુપ્રવ સરકાર, મને તો નામ યાદ નથી, કે તો મારા 25 વર્ષના ઇતિહાસ બહુ જૂના નામ છે. 3 કે 4 વર્ષ તો બેઠા હોય એવા વિદ્યાર્થી. 9મા ધોરણમાં સિલેક્ટ થઈ ગયો એ આઈએમઓમાં. 9મું 10મું 11મું 12મું 4 વર્ષ. વિચારો આવા વિદ્યાર્થી પણ છે. એ વિદ્યાર્થીઓ અમે ભણ્યા અત્યારે એ બધા ફેકલ્ટી તરીકે કામ આવ્યું. જે મહિનો ટ્રેનિંગમાં લોકો ઘણું કામ આવે છે. ઇવન અમારા કરતા સારું કરે છે. They are performing well and they are supporting our Indian team in great form. એટલે આ થઈ કે રીતે પ્રોબ્લેમ સિલેક્ટ થાય ને એ બધું. હવે આપણે નેક્સ્ટ પ્રોબ્લેમ પર જઈએ. હવે એલ્જીબ્રા દેખાય પણ ના એલ્જીબ્રા એટલો બધો નથી. હવે નંબર થિયરી બી છે થોડું. બહુ ટૂંકાણમાં સોલ્યુશન લખી બહુ ઓછાને ખબર પડે. 3 લાઈનનું સોલ્યુશન. એવા પૂર્ણાંકો x અને y શોધો કે x³ બરાબર y³ + 2y² + 1. ક્યુબ ઘન છે. ડાબી બાજુ x³ છે પણ જમણી બાજુ પરફેક્ટ ક્યુબ નથી. તો પરફેક્ટ ક્યુબ બનાવવામાં જમણી બાજુ શું ખૂટે છે જરા વિચારો. એટલું વિચારો તો તમારે રસ્તો મળી જાય. થિંક અબાઉટ ધીસ. y³ છે પછી કંઈક વધારાનું ઉમેરેલું 2y² એ પોઝિટિવ નોન નેગેટિવ +1 એટલે તમારો y³ કરતા કોઈ મોટો ક્યુબ હશે. તો મોટો ક્યુબ મને નજીકનો યાદ આવે y + 1 નો ક્યુબ. તો y + 1 ક્યુબ નું એક્સપાન્શન કરીએ તો y³ + 3y² + 3y + 1. એટલે જમણી બાજુ મારે 3y² + 3y હોવું જોઈએ. એટલે જમણી બાજુ હજુ મારે y² અને 3y ખૂટે છે. તો માની લો કે y² + 3y ટેમ્પરરી માની લઈએ પોઝિટિવ છે. તો એ જમણી બાજુ એડ કરીએ તો જમણી બાજુ મોટું થશે. કોણ થશે? y + 1 નો ક્યુબ. એટલે y + 1 ક્યુબ > x³ થાય. અને x³ તો > y³ છે કારણ કે x³ બરાબર જુઓ તો y³ + નોન નેગેટિવ પોર્શન. x³ એક ક્યુબમાં કંઈક ઉમેરેલું છે. ઉમેરેલું પણ છે નોન નેગેટિવ. રાઈટ. એટલે એ ઉમેરવાથી તમારો y + 1 નો ક્યુબ થાય. એટલે કે તમારો x³ y³ અને y + 1 ના ક્યુબની વચ્ચે આવે છે. y ઇન્ટીજર છે, y + 1 ઇન્ટીજર, બે ઇન્ટીજર નો ક્યુબ. તમે વિચારો ધારો કે 2 નો ક્યુબ 8 અને 3 નો ક્યુબ 27. તો 8 અને 27 વચ્ચે કોઈ ક્યુબ આવે? ના જ આવે ને. 8 પછી નો ક્યુબ છે 27. એટલે એની વચ્ચે x³ નામની સંખ્યા હોય જ નહીં. એનો અર્થ એમ થયો કે આપણે જે ધાર્યું કે y² + 3y પોઝિટિવ છે એ ખોટું છે. કે એ કરવાથી બે પૂર્ણાંક ઘનની વચ્ચે બીજો એક ઘન વધારાનો આવે છે. એ ક્રમિક પૂર્ણાંક ક્યુબની વચ્ચે એક નવો ક્યુબ આવે છે. ધેટ ઇઝ નોટ પોસિબલ. એટલે એનો અર્થ એમ થયો કે તમે જે ધાર્યું y² + 3y પોઝિટિવ એ << 0 હોવું જોઈએ. આ એક ક્વોડ્રેટિક ઇનઇક્વાલિટી થઈ ગઈ. એના બે ફેક્ટર પાડો y × y + 3. એટલે કાં તો y એ ક્વોડ્રેટિકના ફેક્ટર પાડીને સોલ્વ કરો તો તમને y ની 3 જ વેલ્યુ મળશે -3 -2 -1 0. એ થોડું નાનું મેથેમેટિક્સ છે. તમે સારા વિદ્યાર્થીઓ આરામથી કરી શકે. આ કેવી રીતે આવ્યું? હું તો આમ વિચારું એને. y² + 3y << 0. y સ્ક્વેર છે સોરી, એટલે કે y into y plus 3 less than or equal to 0. y into y plus 3 0 ના બે ભાગ પડે. y આમ તમે રીલ લાઈન ડ્રો કરો, અમારે લાઈન ડ્રો કરી શક્ય નથી પણ સમજાઈ ગયું. y0 ને y -3 અને એનો પ્રોડક્ટ લેસ ધેન ઓર ઇક્વલ ટુ 0 છે. એનો અર્થ એમ થાય કે y into y plus 3 લેસ ધેન ઇક્વલ ટુ 0. જો y પોઝિટિવ હોય તો y plus 3 નેગેટિવ થાય, y plus 3 નેગેટિવ તો y પોઝિટિવ થાય, એવું થાય. બંને એક સરખી સાઇન ના હોય એટલે y એટલે બે કેસ બને. આમ આપણે આમ કરવું પડે. કેસ 1 y less than or equal to 0 and y plus 3 greater than or equal to 0, or y greater than or equal to 0 and y plus 3 less than or equal to 0. પહેલામાં શું થશે? પહેલામાં કહે છે કે y greater than or equal to 0 and y less than or equal to 0, sorry, and y greater than or equal to -3. એટલે આ બંને ભેગું કરો તો y બરાબર -3 -2 -1 અને 0 થાય. ખ્યાલ આવ્યો? હવે આ શક્ય નથી. જો y greater than equal to 0 અને y plus 3 less than equal to 0 હોય તો આમ થશે y greater than equal to 0 and y less than or equal to -3. એક બાજુ તમે કહો છો y greater than equal to, બીજી વખત y -3 થી ના, એટલે બે સાથે જ ઇમ્પોસિબલ જ થાય. એનો અર્થ કે આટલા જ સોલ્યુશન થાય. આજે આપણે કરે ને આ આટલી જ પોસિબિલિટી, 4 પોસિબિલિટી મળી ગઈ. હવે 4 y મૂકો ને એટલે x ની વેલ્યુ મળે, એ જો પૂર્ણાંક મળી ગઈ, x ક્યુબ થવો જોઈએ. બરાબર? એ આપણું પ્રેઝન્ટેશનનો હાર છે. આમાં એ મેં ઉડાડી દીધું પણ તમે જાતે વિચારી શકો. એટલે -3 -2 અને -1 માટે નહીં થતું. જો હું y -1 લઉં તો જમણી બાજુ થશે x ક્યુબ બરાબર 2. x ક્યુબ બરાબર 2 થાય એવો કોઈ પૂર્ણાંક નથી x, એટલે એ નીકળી ગયું. એટલે 3 જ કેસ થાય. આ રહ્યા બરાબર. શોર્ટ એન્ડ સ્વીટ સોલ્યુશન. એલ્જીબ્રા આવ્યું. બે પરફેક્ટ ક્યુબની વચ્ચે કોઈ ક્યુબ ના હોય, થોડુંક નંબર થિયરી કહેવાય એમ, એ જ. બાકી બરાબર એલ્જીબ્રા જ કહેવાય પ્યોર. અને ક્વોડ્રેટિક ઇનઇક્વાલિટી આવી. ક્વોડ્રેટિક ઇનઇક્વાલિટી મોટા ભાગે 10th માં સ્કૂલમાં છોકરાઓ જાણે છે. સ્ટુડન્ટ્સ નો હાઉ ટુ સોલ્વ ક્વોડ્રેટિક ઇક્વેશન એઝ વેલ એઝ હાઉ ટુ સોલ્વ ક્વોડ્રેટિક ઇનઇક્વાલિટીઝ. પર રાઈટ હેન્ડ સાઈડ રિયલાઇઝ થવું જોઈએ કે there is something related to y plus 1 whole cube. ઇક્વેશન જોઈને રિયલાઇઝ થવું જોઈએ. એટલે જે આ ઇન્ટ્યુશન છે એ થોડી પ્રેક્ટિસથી આવે. Mathematics is not like formula and solve problem, formula and solve. No. How to create formula, who has created formula, in which manner, that is second level of mathematics. પેલું ઉપરનું ફોર્મ્યુલા આપો દાખલા ગણો એ સરફેસ લેવલનું મેથમેટિક્સ કહેવાય. ઇટ્સ નોટ મચ વેલ્યુ. Of course, in applied mathematics, it has some value, but real mathematician hardly think about. They create formula and भूल जाओ. Let's use this formula. आपको क्या है, right? Very good. આ પ્રોબ્લેમ ઇન્ટરેસ્ટિંગ છે. In a 4x4 array of 16 numbers. The sum of the numbers in each row, each column, and each of the diagonal is 1. Find the sum of the numbers in the four corners of the array. મેજિક સ્ક્વેર છે. દરેક લાઈનમાં, દરેક હારમાં ચારે એલિમેન્ટનો સરવાળો એક જ થાય છે. આપણે એકના બદલે એસ લઈએ તો પણ ચાલશે. દરેક કોલમમાં પણ એવું થાય છે અને બે ડાયોગનલમાં પણ એવું થાય છે. તો કોર્નર ઉપરના નંબરનો સમ કેટલો? તો આના માટે એક ટેબલ બની તો વધારે સારું આવે. લેટ મી ઓપન ધ વર્ડ ફાઇલ. છે ટેબલ. some values are there. વેલ્યુ લખતો નથી. ફોર એક્ઝામ્પલ A, B, C, D, X, Y, Z, W, P, Q, R, S, L, M, N, O. આવું આપેલું છે. What is the property? Sum of all the elements in any row is 1. Same thing in column, same thing in row diagonal. તો જો આમ થાય અને આટલા બધા વેરિયેબલ્સ અહીં કરીશું થોડું કંટાળો હશે મને નહીં તમને બે નહીં. આના શોર્ટકટ બનાવીએ. શોર્ટકટ મેં સોલ્યુશનમાં લખીએ જો પછી આપણે આમાં જઈએ. લેટ એસ બી ધ મેજિક સમ. પેલો 1 ના બદલે આપણે એસ લખીએ તો ચારે ચાર રો એડ કરીએ તો ટોટલ 4s થાય. બરાબર. હવે ચાર રો એડ કરી. હવે બે મિડલ રો અને બે મિડલ કોલમ નો સમ બી 4s થાય. એટલે 0 = 4s - 4s. હવે તમે જુઓ બધા 16 એલિમેન્ટ લઈ લીધા. એમાંથી વચ્ચેની બે રો અને વચ્ચેની બે કોલમ બાદ કરી નાખી તો વધ્યું શું? પેલા કોર્નરના 4 એલિમેન્ટ્સ. અને કયું બે વખત બાદ થયું? પેલા મિડલ 4 એલિમેન્ટ્સ. એટલે જો હું અહીંયા કલરથી બતાવું. તમે આ જે છે આ એક રો લઈ લીધી મેં. ધારો કે સિલેક્ટ કરી એટલે હું કલર આપી દઉં રેડ. પછી બીજી આ લીધી. એ પણ રેડ. પછી ત્રીજી આ કોલમ લીધી. થર્ડ રો ઇઝ ધીસ. એ પણ રેડ. અને ચોથી આ લીધી. એ પણ રેડ. એટલે મેં કેટલું કર્યું? S + S. બરાબર. હવે હું કંઈક સબટ્રેક્ટ કરું. સબટ્રેક્ટ કરું હું કલર બદલીશ. બરાબર. ધ્યાનથી જોજો. બે મિડલ કોલમ નંબર 2 એનો કલર આપું. સબટ્રેક્ટ કરવાનો કલર અલગ આપું. એટલે -s. આ કોલમ બી સબટ્રેક્ટ કરો એટલે કે -s. આ મિડલ રો સબટ્રેક્ટ કરો હવે રો સબટ્રેક્ટ કરું તો એનો કલર અલગ આપું છું. એટલે માઇનસ એસ અને આ સબટ્રેક્ટ કરો. દેટ મીન્સ માઇનસ એસ. પણ આમ કરવાથી ધ્યાનમાં રાખો, ચાર જે ખૂણાના છે એ રેડ બદલાય નહીં. આ સરવાળો તો 0 જ થવાનો. 4s બરાબર 4s માઇનસ 4s બરાબર 0. પણ બીજી રીતે જોઈએ તો તમે આ કરવાથી કયા એલિમેન્ટ બાકી રહી ગયા? a પ્લસ ડી પ્લસ એલ પ્લસ ઓ, આ 4 બાકી રહી ગયા. એગ્રી? કયા એલિમેન્ટ 2 વખત બાદ થયા? એ 2 વખત બાદ થયા. જો y નામનો એલિમેન્ટ સેકન્ડ કોલમમાં બી છે ને સેકન્ડ રોમાં જ એ થયો. y z q r. આ તો આને અલગ કલર આપીએ. કલર નું કોમ્બિનેશન શોધવું અઘરું છે. કયો કલર આપીએ? સેજ બ્લુ આપ્યા. એ 2 વખત સબટ્રેક્ટ થયા. એટલે એક વખત એને એડ કરવા પડે. 2 વખત તમારી પાસે છે. પહેલી વખત બધા 16 એલિમેન્ટ્સ આવ્યા હતા, બધા એક વાર આવ્યા હતા. એટલે તમે ભૂલથી એક વધારાનો સબટ્રેક્ટ કરો. એટલે બેલેન્સ કરવા માટે એ તમારે લેવા પડે. Sorry, એ સબટ્રેક્ટ આવશે. I made a mistake. Am I right? Let me check. માઇનસ આવશે. બરાબર? એટલે એનો અર્થ એમ થયો કે આ 2 બ્રેકેટનો ડિફરન્સ, the difference of these 2 bracket is 0. Therefore both the brackets have equal value. Shall I write like this? Clear? હવે બીજી રીતે વિચારીએ. Take the sum of two diagonals. Now s plus s. ડાયગોનલ સમ પણ સેમ છે. તો પહેલા ડાયગોનલ શું થશે? a પ્લસ y પ્લસ r પ્લસ o પ્લસ l પ્લસ q પ્લસ z પ્લસ d. ઉપરના 2 બ્રેકેટની વેલ્યુ ઇક્વલ છે એટલે આ બ્રેકેટ બી ઇક્વલ થાય એટલે આ થશે. હા, આ સમને હું જરા બીજી રીતે રાખું, રીરાઇટ કરું આ સમ. summation is commutative એટલે a પ્લસ d પ્લસ l y પ્લસ r z પ્લસ q. આમ લખાય. હવે જો આ 2 બ્રેકેટ ઇક્વલ છે ને એ બંને બ્રેકેટનો સમ 2s છે. So that is equal to 2 times this. The 2s equal to this. તો 2 કેન્સલ થઈ જાય બંને બાજુથી. That means we are getting s equal to this. એટલે જો 4 કોર્નરનો સમ એસ થઈ ગયો. જો લુક એટ ધીસ ટેબલ, a પ્લસ b પ્લસ l પ્લસ o. એઝ અ બાય પ્રોડક્ટ 4 મિડલનો બી સમ સેમ થયો, કારણ કે મિડલ 4 મિડલ વેલ્યુ ઇક્વલ ટુ 4 કોર્નર વેલ્યુ સમ. વેરી ઇન્ટરેસ્ટિંગ. નહીં તો 16 વેરિયેબલ થી ઇક્વેશન્સ બનાવો અને બધું અઘરું પડે, પણ આમ થોડુંક વિઝ્યુલાઇઝેશન થાય કે આમ લો તો જલ્દી થાય. એટલે આમાં ઓરિજિનાલિટીની જરૂર છે. ઓલિમ્પિયાડમાં ભલે ઓછા પ્રોબ્લેમ સોલ્વ થાય. આરએમઓ ની વાત કરું, આરએમઓ શું 6 પ્રોબ્લેમ પૂછાય છે, 4 કલાકની એક્ઝામ. 4 કલાકની કે 3 કલાકની, હું ભૂલી ગયો છું. હા, 4 કલાકની જ હશે. ઇગ્મો 4 કલાકની ને આરએમઓ 3 કલાકની. 3 કલાકમાં 6 પ્રોબ્લેમ પૂછાય. 3 hours એટલે 180 મિનિટ્સ. 180 મિનિટ્સ અને 6 પ્રોબ્લેમ એટલે 30 મિનિટ્સ એક પ્રોબ્લેમ સોલ્વ કરવાનો. સમજી લો કેટલા અઘરા પ્રોબ્લેમ હશે. અને ઓરિજિનલ એટલે આરએમઓ ક્રેક કરવી બી અઘરી છે. એ આપણે રૂટીન બધા કોચિંગ ક્લાસીસમાં જે શીખ્યા છે એ લોકોનું કામ નહીં. આ બધા એ બધી ઊંચી વાતો કરે, પણ ઓરિજિનલ હોવું જોઈએ સબ્જેક્ટમાં. હા, એકાદ બે કોઈ ક્લાસીસમાં સારા ટીચર હોય તો તમને આવું કરે, પણ સ્ટુડન્ટે જાતે કરવું પડે. દેટ ઇઝ વન પોઈન્ટ. ડુ ઇટ યોર સેલ્ફ વિધાઉટ ટેકિંગ ધ હેલ્પ ઓફ ટીચર. યુ કેન રિફર ધ બુક, બટ યુ હેવ ટુ કમ અપ વિથ યોર સોલ્યુશન. હું કોઈ પ્રોબ્લેમ પૂછું, મને એનું સોલ્યુશન ખબર છે, હું તમને આપું. તમે જો મારા કરતા બીજું સોલ્યુશન લાવશો, ભલે લાંબુ હશે કે ટૂંકું હશે, એ બહુ મહત્વ નથી, પણ ધેટ સોલ્યુશન હેઝ મોર વેલ્યુ than my solution, because you have solved at your own. ઓરિજિનાલિટી નો બહુ ઇમ્પોર્ટન્સ છે. આમાં મેમરી બેઝ નથી. મને ઘણી વસ્તુ યાદ નથી રહેતી તો એમાં ચાલી જાય. યાદ રહે શક્તિનો મહત્વ નથી. તમે મેથેમેટિકલ કેવું વિચારો છો, હાઉ યુ થિંક, એનું ઇમ્પોર્ટન્સ છે. ક્લિયર? એટલે આ પ્રોબ્લેમ બહુ સરસ છે એલ્જીબ્રાનો. નેક્સ્ટ પ્રોબ્લેમ જોઈએ. હા, મેં શોર્ટમાં સમજાવ્યું. આમાં જો, આમાં કહ્યું ખબર ઓછી પડે, પણ બરાબર ધ્યાન રાખો તો પડી બી જાય. સિગ્મા કોર્નર એટલે કોર્નરના 4 એલિમેન્ટો સર, મિડલ 4 એલિમેન્ટો સમ. That is sigma corner equal to sigma middle. Adding two diagonal elements, so 2s. 2s equal to sigma corner plus sigma middle. Therefore, sigma corner is s. Sigma middle is also s. Short and sweet. Next problem. Let a be equal to -1, -2, -3, etc. -n, where n is a natural number. For each non-empty subset of A, we determine the product of the elements. What is the sum of all such elements? આવું તો વિચાર જ ના આવે. એટલે મારે શું કરવું પડે આને? પ્રોબ્લેમ ના ઉકેલ તરફ કઈ રીતે જો? આ તો હું લખી કાઢું છું એટલે ઉકેલ મને મજા ના, હું તો આ રીતે કરું. આ પ્રોબ્લેમ છે. મેથેમેટિકલ એક્સપેરિમેન્ટ કરવાનો હોય. સપોઝ n equal to 1. So your A set will be -1. એનો નોન યુનિટ સબસેટ એકલો થશે એટલે -1 is answer. આપણને મળ્યું કે f of 1 equal to -1. હવે બીજું જોઈએ. સપોઝ n equal to 2. આવું એક્સપેરિમેન્ટ કરવું પડે એટલે -1, -2. તો એના સબસેટ્સ કયા કયા આવશે? નોન એમ્પ્ટી લેવાના છે. એક -1, એક -2 અને -1 નોન એમ્પ્ટી. તો એના પ્રોડક્ટ કયા આવશે? -1 નો એક -1, -2 માટે -2 અને -1 અને ઇન્ટુ -2 એનો પ્રોડક્ટ કરો તો 2 આવશે. એટલે F2 equal to F2 call the summation of such. તો બે બી સમ જો એનો સમ બરાબર ધ્યાનથી જો શું આવે છે? જો -1 જ આવે છે. એટલે એક फीलिंग આવ્યું મને कि कांस्टेंट सम होगा -1, लेकिन फिर भी एक लेट मी ट्राई फॉर वन मोर वैल्यू n इक्वल टू 3. -1, -2 -3 -1 2 -1 -3 -1 -2 -3 sorry minus sign and the set A itself. F3 શું થશે? જો બરાબર ધ્યાનથી જુઓ. પહેલો -1 નો સમ એટલે -1, પછી -2, પછી -3, પછી +2, પછી +3, પછી +6 અને છેલ્લે -6. તો બોલો -1 જ આવે છે. એટલે આપણને એક ગટ્સ આવે, ફિલિંગ આવે છે કે f of n must be equal to -1. But how to prove in general? This is feeling. Mathematics of feeling नहीं, mathematical authentic proof चाहिए. Guts, we should be able to claim, should be able to prove. કેવી રીતે પ્રૂવ કરવું? પણ એક્સપેરિમેન્ટ એની નાની નાની વેલ્યુથી કર્યું તો આપણને આવું ફિલિંગ આવી ગયું. હવે ફિલિંગ પરથી એને મેથેમેટિકમાં કન્વર્ટ કરું ત્યાં આપણા થોડી પ્રેક્ટિસની જરૂર પડે. फीलिंग लाओ માટે एक्सपेरिमेंट, इंट्यूशन हो, इंट्यूशन से भी आ सकती है या थोड़ी प्रैक्टिस कर ये एक्सपेरिमेंट करके लाओ. फिर आने के बाद प्रूव करना है, थोड़ी इंटेलिजेंस रिक्वायर्ड, मैथमेटिकल इंटेलिजेंस. हाउ शुड वी शुड बी एबल टू प्रूव दैट्स इम्पोर्टेंट. કેવી રીતે પ્રૂવ કરો? તો લેટ અસ સી અવર ઓફિશિયલ સોલ્યુશન. તમે એક સબસેટ લો એનો નોન એમ્પ્ટી, ફોર એક્ઝામ્પલ -1/2 -1/k with y1 less than y2 less than k. There exists a unit term x into y1, x into y2, x into y2 in the expansion. of this new expression. M બરાબર નવું expression બનાવ્યું, product of 1 plus xi minus 1. And for each term xa1, xa1 to ak in the expansion of M, there is a unique non-empty subset C equal to minus 7 into ak minus ak of A. Thus, the required sum is the value of M for each xi equal to minus I. સૂઝે જ નહીં આવું. નંબર થિયરી છે, સેટ થિયરી છે, ને ક્યાં એલ્જીબ્રા લાયા? એટલે આજે પોલિનોમિયલ એમ શોધ્યું છે, એ એમ વિચાર કરે, એ સલામ મારવા જેવું છે. M equal to product 1 plus xi, I varies from 1 to n minus 1. It's something interesting. Yes or no? આવું વિચાર કઈ રીતે આવે? એ કર્યા પછી એમ કહે છે કે તમે કોઈ પણ સબસેટ બી લો એ નો નોન એમ્પ્ટી, ફોર એક્ઝામ્પલ -y1 -y2 -k with y1 less than y2 less than yk of a, તો એના એક્સપાન્શનમાં એક યુનિક ટર્મ આવશે જે આવી આવશે xy1 xy2 xyk. અને ઊંધો, સપોઝ તમારી પાસે એવી ટર્મ હોય xa1 xa2 xak, આ એક્સપાન્શનને લીધેલી, તો તેના માટે એક સેટ મળશે -a1 -a2 એટસેટ્રા -ak. એનો અર્થ એમ કે તમારે જે બધો સમ શોધવો છે એ આના xi બરાબર -i મૂકી દો તો આપણું કામ થઈ જાય, કારણ કે આવું જો સેટ એ કેવો છે -1 -2 -3 -n. બરાબર? એને હું તમને બીજી રીતે સમજાવું. સી, આપણે એમને સીધો આ જ લઈએ, 1 -1 1 -2 1 -3 એટસેટ્રા 1 -n. આને એક્સપાન્ડ કરી, ભલે 1 -1 0 થાય, આપણે 0 નથી લેતા, આપણે બધું એક્સપાન્ડ કરવું છે. તો બધા પહેલામાંથી 1 1 લીધા, મલ્ટીપ્લિકેશન આવશે, એ 1 એક્સ્ટ્રા ટર્મ થઈ, તો એને સબટ્રેક્ટ કરીને 1 આપણે સબટ્રેક્ટ કરી નાખીએ, એટલે બધું. હવે કોઈ બી એક્સપાન્સિવ જોશો તો પેલા નોન એમ્પ્ટી સબસેટનો એક ટર્મ જ હશે, પ્રોડક્ટ. Again I am repeating, if we expand this M completely, then each term correspond to the product of all the elements of some non-empty subset of A, and every non-empty subset of A corresponds to a one of the terms of the RHS expansion of M. Like 1 correspondence થઈ ગયું, અને બધી ટર્મનો સમ કરવાનો છે, પ્લસ એક્સપાન્શન કરો એમાં પ્લસ આવવાનું છે. પણ આ એક્સપાન્શન તો મારા માટે સહેલું છે, કારણ કે 0 -1 જ છે. જુઓ, કારણ કે 1 -1 0, 0 into anything is 0. આ સૂઝવું અઘરી વાત છે. અઘરી મીન્સ તમારી ટેલેન્ટને બહાર લાવવા માટે આવું સુધારવું જરૂરી છે, એમ બી કઈ ચાલે. ક્લિયર? નેક્સ્ટ પ્રોબ્લેમ. px એક પોલિનોમિયલ છે જેના કોએફિશિયન્ટ્સ બધા ઇન્ટીજર છે. લીડિંગ કોએફિશિયન્ટ x ની મહત્તમ ઘાતનો સહગુણક, અચળ પદ અને p(1) આ ત્રણેય અયુગ્મ છે. અયુગ્મ પૂર્ણાંક, કારણ કે બધા કોએફિશિયન્ટ ઇન્ટીજર છે. તો px ને કોઈ સમય બીજ નથી, રેશનલ રૂટ નહીં है. એ રીતે કરીશું. જોઈએ. px બરાબર આવ્યું પોલિનોમિયલ લીધું. આખું પોલિનોમિયલ લખવું એના કરતા સિગ્મા નોટેશન વાપર્યું. ak x રેસ ટુ k ak minus 1 x raised to k minus 1 plus ak minus 2 x raised to minus 2 વગેરે વગેરે a1 a2 x square plus a1 x plus a0. આવું એક આપણું પોલિનોમિયલ છે કે જેમાં ak ઇન્ટીજર છે, અરે ak ઓડ છે, a0 ઓડ છે, બધા જ કોએફિશિયન્ટ્સ ઇન્ટીજર્સ છે અને p of 1 ઓડ છે. આ ચાર વસ્તુ આપેલી છે. બધા જ કોએફિશિયન્ટ ઇન્ટીજર, ak ઇન્ટીજર, a0 ઇન્ટીજર અને p of 1 ઓડ. તો એનું સમય બીજ ના હોય, રેશનલ રૂટ ના હોય. તો જો આપણે ધારી લઈએ કે x equal to m by n એનું રૂટ છે અને રેશનલ છે એટલે m અને n ને બધા જે ફેક્ટર કટ કરી નાખવાના એટલે એનો જીસીડી ઓફ m and n 1 વી કેન એઝ્યુમ. તો x ની જગ્યાએ મૂકી દો m by n, સિમ્પ્લિફાય કરો, સિગ્મા ai m by n રેસ ટુ i ઇક્વલ ટુ 0. n રેસ ટુ i થી બંને બાજુ મલ્ટીપ્લાય કરો એટલે આપણને આવું મળે, સિગ્મા ai m રેસ ટુ n રેસ ટુ k થી મલ્ટીપ્લાય કરો તો ai mi m રેસ ટુ i n રેસ ટુ k માઇનસ i 0. 0 તો E1 કહેવાય એટલે LHS ની વેલ્યુ 0 E1 છે એમ કહેવાય, 0 છે એટલે. હવે જો ઓડ કોઈ બી ઓડ ઇન્ટીજર અને E1 માઇનસ ઓડ તરીકે લખી શકાય. પહેલો E1 કોણ છે કે જે ઉપર આપણે કર્યું, સિગ્મા ai m રેસ ટુ i n રેસ ટુ k માઇનસ i. બીજો ઓડ કોણ છે, સિગ્મા a, કારણ કે p of 1 ઓડ આપી, p of 1 મૂકો તો સિગ્મા ai તો ઓડ જ થાય ને. અહીંયા મારી ભૂલ છે, સિગ્મા ai હોવું જોઈએ, i કાઢી નાખે ai હોવું જોઈએ, પ્લીઝ બી કેરફુલ. કરેક્શન હે કે તો સિગ્મા ai ઇઝ ઇક્વલ ટુ i ઇક્વલ ટુ 0 ટુ k ai છે. આ થોડું કરેક્શન છે અહીંયા. ધીસ સમેશન હેઝ સમ કરેક્શન. એટલે ટૂંકમાં ai કોમન નીકળે, બ્રેકેટ m રેસ ટુ i ઇન્ટુ n રેસ ટુ k માઇનસ i માઇનસ 1 ઇક્વલ ટુ ઓડ. હવે m ઇઝ અ ફેક્ટર ઓફ ai, a0, કારણ કે m જો બધામાં m ક્યાં ક્યાં છે, x રેસ ટુ k માં m આવે, x રેસ ટુ k માઇનસ 1 માં આવે, x સ્ક્વેર માં આવે, x માં ખાલી કોન્સ્ટન્ટ ટર્મમાં ના આવે એટલે કે a0 માં ના આવે. m બધામાં ફેક્ટર છે ને a0 માં ના આવે, RHS 0 છે તો m મસ્ટ ડિવાઇડ a0. એ જ લોજિકથી n મસ્ટ ડિવાઇડ્સ ak. એટલે m અને n બંને ઓડ છે. બંને ઓડ છે તો m રેસ ટુ i પણ ઓડ, n રેસ ટુ k માઇનસ i પણ ઓડ, એટલે ઓડ ઇન્ટુ ઓડ ઇઝ ઓડ, માઇનસ 1 કરો એટલે E1 થાય, એટલે ai ઇન્ટુ E1 એટલે E1, એટલે E1 બરાબર ઓડ આવ્યું, એ કોન્ટ્રાડિક્શન. એનો અર્થ કે આપણી એઝમ્પશન હતું કે આને રેશનલ રૂટ હોય એ ખોટું પડ્યું. Sir, wrong. So my assumption is wrong. So this equation does not have any rational root. Clear? આમાં એલ્જીબ્રાના પ્રોબ્લેમ વધારી દીધા છે, કોમ્બિનેટ્રિક્સના થોડાક લીધા છે, નંબર થિયરી વધારે છે. ખરેખર તો જ્યોમેટ્રીના પ્રોબ્લેમ પણ લેવા જોઈએ. જો ટાઈમ મળે તો આપણે જ્યોમેટ્રીનો પ્રોબ્લેમ પણ લઈશું એકાદો, ટાઈમ પરમિટ્સ. આ જો each of the numbers a1 a2 an દરેક A1 A2 AN 1 કે -1 માંથી છે. અને બરાબર ધ્યાનથી જુઓ, A1 ઇન્ટુ A2 ઇન્ટુ A3 ઇન્ટુ 4, આ ચારનું મલ્ટીપ્લિકેશન 1 કે -1 જ આવવાનું છે. કે બધા 1 1 નો પ્રોડક્ટ -1 એટલે 1 કે -1. એવું બીજું A2 A3 A5 સુધી છેલ્લે AN થી AN A1 A2 આ બધાનો સમ 0 છે. પ્રૂવ ધેટ n is a factor of n is a multiple of 4. Right? કેવી રીતે વિચાર કે સૂઝે કેવી રીતે? કે આ રીતે સમ 0 થાય તો 100% કે n is a multiple of 4 અથવા 4 divides n. દરેક ટર્મની વેલ્યુ 1 કે -1 છે. નંબર ઓફ ટર્મ્સ n છે. જો પહેલામાં ફર્સ્ટ એલિમેન્ટ A1, બીજામાં સેકન્ડ એલિમેન્ટ A2, છેલ્લામાં ફર્સ્ટ એલિમેન્ટ AN, એટલે કુલ n ટર્મ્સ છે. હવે n ટર્મ્સ 1 કે -1 એ બધાનો સરવાળો કરો અને 0 આવે. n ટર્મ્સ છે તો n ઇવન જ હોય, અને ઓડ તો ના હોય. ઓડ નંબર ઓફ ટર્મ્સનો ઓડ નંબર ઓફ 1 કે -1 નો સમ ક્યારે 0 ના આવે, ઇવન માં જ થાય. ઇવનમાં અડધા ઓડ, અડધા +1 અને અડધા -1 હોય તો જ થાય એમ. એટલે n ઇવન છે દેખીતું છે, પણ આ તો વધારે સ્ટ્રોંગ બતાવવાનું છે કે n ડિવિઝિબલ બાય 4. કેવી રીતે કરીશું? સમેશન 0 આપેલો છે. માની લો કે મારો A1 નેગેટિવ છે. ટેમ્પરરી માની કે સપોઝ A1 is -1. તો A1 વાળી ટર્મ્સ ક્યાં ક્યાં આવવાની? A1, A2, A3, A4 આ એક ટર્મ્સ હશે. બીજી AN -3, -2, AN -2, n -1. હું આ બ્રેકેટ કરું તો ખ્યાલ હશે. સબસ્ક્રિપ્ટ નું મારે હા આ રીતે. આમાં A1 દેખાય જો. પછી ક્યાં આવશે વિચારો જરા. A1 વચ્ચે બી આવે ને. ધારો કે અહીંયા A1 આવ્યો તો અહીંયા A2 આવશે, અહીંયા A3 આવશે, અહીંયા AN આવ્યું. A1 પહેલું છે, A1 છેલ્લું છે. આપણે ક્રમ બદલીએ. હા, હવે A1 ક્યાં આવશે? ત્રીજા પદમાં. એનો અર્થ કે અહીંયા AN -1, AN, A1, A2 અને ચોથું તમારું આ થશે. આ ચાર જ ટર્મ્સમાં A1 આવવાનું. જો હવે આપણે પેલા ક્વેશ્ચન કે જો હા અહીંયા છે ને A1 -1 હોય અને ચેન્જ ટુ A1 equal to +1. એટલે આની સાઇન બદલાઈ જશે, આની સાઇન બદલાઈ જશે, આની સાઇન બદલાઈ જશે, આની સાઇન બદલાઈ જશે, કારણ કે એક જ જગ્યાએ A1 બદલાય છે, +1 થયું -1 થઈ જાય છે. ચાર જ પદની સાઇન બદલાશે. પહેલા સમ 0 છે, ચાર જગ્યાએ સાઇન બદલાય છે, એટલે સાઇન બદલાય વેલ્યુ તો 1 કે -1 છે. એટલે જુઓ તમે વેલ્યુની દ્રષ્ટિએ વિચારો, ટેબલ બનાવો તો વધારે ખ્યાલ આવે. ધારો કે અહીંયા +1 છે, આ ચારે ચાર ટર્મની +1 છે, તો હવે જો પેલી વેલ્યુ બદલાય તો -1 થાય. -1 થાય. કેસીસ તમને શોર્ટમાં લખું T1, બરાબર? શોર્ટ આપણે વાપરીએ એટલે મારે બહુ જગ્યા રોકવી ના પડે. આ T2 સેકન્ડ ટર્મ, 3 2 ચોથી ટર્મ. હવે એ બદલાઈ ગઈ એટલે T' કહીએ એને. Yes, any question? Case 1, case A, case B. Suppose કંઈક આવું છે 1 1 -1 -1. તો 1 will become -1, -1 will become -1, -1 will become 1, -1 will become 1. સપોઝ આવું છે 3 ones, 1 1 1 અને -1. તો this become -1, this become -1, this become -1 and this become 1. બરાબર? આ સેપરેટર લાઈન, બસ એટલા માટે, બીજું કઈ નહીં. બરાબર? એટલે 3 1 અને -1. ચોથો કેસ 2 1 અને 4 4 ગણો તો 2 1 અને 2 -1 બી થઈ ગયો. હવે 1 1 3 -1. એટલે આ -1 1 1 1. હવે કે બાકી રહ્યા કેસ જુઓ તો આપણે એક વધારાની કોલમ બનાવીએ. ચેન્જ ઇન સમ. પહેલા 3 1 હતું અને 3 -1 થયું એટલે ઘટ્યો સમ. એટલે પહેલા S હોય તો હવે S -4 થયો. 4 એક હતા અને 4 એક હતા એટલે એ જતા રહે એટલે -4 કરવા પડે અને બીજા -4 ઉમેરાય એટલે s -8 થયું. એમાં રાઈટ આમાં જો 2 1 2 -1 તો એ જે +1 ના -1 થયા બીજા માઇનસ એટલે s નો s જ સમ રહ્યો. 3 1 3 -1 તો જો 3 1 1 -1 એટલે પહેલા s હતો સમ એમાં 3 1 નીકળી ગયા 3 1 નીકળ્યા એટલે -3 કરવું પડે 1 -1 નીકળી ગયા એટલે +1 કરવું પડે. ટૂંકમાં નેટ ટ્રોફી જોઈએ આપણે જુઓ 3 1 અને -1 એનો કુલ સમ થશે તમારો થશે 2 અને પેલી બાજુ જે બદલાય -1 -1 -1 1 એનો કુલ સમ થશે -2 એટલે તમારો સમ 2 નો -2 થયો એટલે કે 4 ઘટ્યા 4 બાદ થયા. આમાં જુઓ આમાં 4 છે 4 ટર્મનો સમ થશે -2 અને નવો 4 નો થશે +2 એટલે 4 વધ્યા. એટલે કહેવા શું માંગીએ છીએ કે ઓરિજિનલ સમ s હોય તો પછી આ રીતે એક જો ટર્મ -1 છે એને હું +1 બનાવું તો કાં તો અહીં સમ s રહે કાં તો s -8 રહે કાં તો s -4 રહે કાં તો s +4 રહે. ક્લિયર? ફરીથી એક્સપ્રેશન જુઓ એમાં જ્યાં બી નેગેટિવ હોય નેગેટિવ પર હુમલો કરો એને +1 કરો એક જ નેગેટિવ ને ધારો કે a2 હોય તો એ 4 જગ્યાએ ફેર પડે તો આ 4 જ વેલ્યુ થશે. બરાબર? એટલે ન્યુ s માઇનસ ઓલ્ડ s is divisible by 4. Divisible by 4. આ પ્રક્રિયા કરીએ વારંવાર રિપીટેડલી જ્યાં જ્યાં -1 એના પર એને બંદૂકની ગોળી +1 થઈ જાય સ્વિચિંગ તો દર વખતે ડિફરન્સ ડિવિઝ હોય 4. છેલ્લે જયારે બધું જ -1 નીકળી જાય તો આપણી જોડે રહેશે શું બધા +1 એટલે a1 * a2 * a3 * a4 જે નવા બન્યા એ 1 * 1 * એટલે 1 થવાનું એ બધા એટલે એ 1 1 1 સમ કરો ટોટલ સમ n થયો. ઓરિજિનલ સમ 0 છે નવો સમ n થયો એટલે ન્યુ s માઇનસ ઓલ્ડ s એનો ડિફરન્સ તો d 4 થયો એટલે આપણે કહી શકાય કે n ઇઝ ડિવિઝિબલ બાય 4. ક્લિયર? આવું સૂઝવું જોઈએ રિયલાઇઝ કે હું સ્વિચિંગ કરું છું કંઈક ઓપરેશન બદલું છું. આ બીજી કોઈ રીતે થતો નથી. મને કોઈ બીજી કરી આપે તો મને ગમશે. આઈ એપ્રિશિએટ all the mathematics community will appreciate, but this is a nice solution. Good. Last problem. A bus ticket number consists of 6 digits is called lucky. The sum of its first digit equals the sum of its last digit. Prove that the number of lucky tickets equals the number of tickets with a sum of all the digits equal to 27. એક એક્ઝામ્પલ નહીં સમજીએ. લકી ટિકિટ એક આવી છે જો 1 2 3 006. કેમ લકી છે? કારણ કે યહાં is the lucky ticket. Reason કે 1 plus 2 plus 3 equal to 0 plus 0 plus 6. આવી કેટલી લકી ટિકિટો એ નથી શોધવાની, હાઉ મેની નથી પૂછ્યું, પણ એમ કહે છે કે એ બીજી ટિકિટ લો કે જેનો સમ 27 થાય. દાખલા તરીકે જો આ સમ 27 છે, તો આવી દરેક ટિકિટ માટે આવી એટલે 27 સમ થાય કેટલી ટિકિટ એ નથી પૂછ્યું, પણ એમ પૂછ્યું છે કે નંબર ઓફ ટિકિટ્સ હેવિંગ સમ 27 and number of lucky tickets are equal. Very interesting. કેવી રીતે ઇન્ટરેસ્ટ આ બંનેનું રિલેશન કેવું લાવો ખબર નથી પડતી. સોલ્યુશન કંઈક આવું છે. લેટ A1 A2 A3 A4 A5 A6 be a lucky ticket. રેનોલ્ડ શું થાય? A1 plus A2 plus A3 equal to A4 plus A5 plus A6. આમ થાય. લકી ટિકિટ હોવા દે. હવે હું એક નવો સમ બનાવું. કન્સિડર ટિકિટ. કઈ ટિકિટ? A1 A2 A3 માં તો કોઈ જ ફેરફાર નથી કરતો. હવે હું A4 છે એની જગ્યાએ હું 9 - A4 લખું. જો A4 5 હોય તો 9 - A4 4 થાય. A4 0 હોય તો 9 - A4 9 થાય. A4 1 હોય તો 9 - A4 8 થાય. એ રીતે એ જ રીતે 9 - A5 9 - A6 આ ટિકિટ લઈ. આ ટિકિટના બધા ડિજિટનો સમ કરીએ તો શું થાય જુઓ તો. આમ થાય. એ સમનું સાદું રૂપ આપી બરાબર જોજો. 9 9 9 જે 3 9 થાય એટલે કેટલા થાય? 2700 થવાના જ. એ 27 આગળ લખીએ 27. તો અહીંયા બાકી શું રહ્યું? માઇનસ A4 માઇનસ A5 માઇનસ A6. પણ આપણને ખબર છે કે A1 A2 A3 6 તો લખી દીધી, એટલે પહેલા ત્રણનો સમ બરાબર પાછલા ત્રણનો સમ. So this is as good as. આ બંને સમ તો સરખા છે બીકોઝ ધ A1 A2 A6 વોઝ અ લકી ટિકિટ. એનો અર્થ કે શું થયો? આ 27 થઈ ગયું. એટલે કે આ બે ટિકિટ, આ એક લકી ટિકિટ હતી અને નવી ટિકિટ બને ટી. If you have one L, you can create T. Conversely સાચું છે. If you have T having sum of the digits 37, તો લાસ્ટ ત્રણ છે એને ફરી 9 માઇનસ કરો તો 9 માઇનસ 9 માઇનસ A4 એટલે A4 થઈ જાય. એવી રીતે A5 6 એટલે એનો બી સમ શું થશે? લકી ટિકિટ થશે. એટલે આપણે શોર્ટમાં લખીએ કે 10 L 10 the set of L and the set of T are in 1 correspondence. એક સંગતતા છે બંને વચ્ચે. એટલે કે નંબર ઓફ L, બંને ફાઇનાઇટ સેટ છે, નંબર ઓફ L is equal to the number of T's. એ લકી ટિકિટ એ પેલા સમ 27 થાય એવી થઈ જાય. ક્લિયર? એટલે અમે 10 પ્રોબ્લેમ લેવાના ધાર્યા હતા અને આપણે 10 સીધા જ્યોમેટ્રીનો લઈ શક્યો એમ નથી, પણ થોડું ડિસ્કશન કરી શકાય. એના માટે શું કરવું પડે? પેન્ટ લેવું પડશે. આ એક રિવર છે. અહીંયા એક પર્સન છે, પર્સન. અને અહીંયા એની કાઉ છે. Sorry, a river flow of water. હવે પર્સન એ નદીમાંથી પાણી ભરીને કાઉ બીને આપવું છે. કાઉ બીને તરસ લાગી, કયા રસ્તે જશે? ઘણા પોસિબિલિટીઝ છે. ફોર એક્ઝામ્પલ અહીંથી આમ જાય અને પછી આમ જાય. ફોર એક્ઝામ્પલ અહીંથી આમ જાય પછી આમ જાય. ફોર એક્ઝામ્પલ અહીંથી મિડ પોઈન્ટ જાય પછી આમ જાય. એવો રસ્તો શોધો એને શોર્ટેસ્ટ ઓછું અંતર કાપવું પડે. સમથિંગ મિનિમાઇઝ ધ ડિસ્ટન્સ. હવે જ્યોમેટ્રીના પ્રોબ્લેમ પણ ઇન્ટરેસ્ટિંગ છે. બહુ સિમ્પલ જ્યોમેટ્રી છે. આજકાલ જ્યોમેટ્રી આપણા સ્કૂલમાં સારી એટલું ડિટેલિંગ નથી બીકોઝ ઓફ સિલેબસ મેથડ. ક્લિયર? સો આઈ થિંક લેટ મી સ્ટોપ. You can think about this. If you have any question, you can feel free to ask. We have 4 minutes.
So Thank you very much, sir. It was a really very nice session, and student really come to know about how these mathematics are really working, like from the calculus part, matrices part, and so student really come to know how these INMO exams, INMO exams, and all these exams are being taken, and how you shared how these problems are being generated and prepared. So all these informations are really helpful for the students, sir. Thank you very much, sir. Now I would like to invite Dr. Poonam Bhargava to do the valedictory of this function.
Thank you so much, Jyotin. And really, it was one of the very interesting presentations, sir, actually on mathematics. Although I am quite far away from mathematics after 12th, but indeed it fascinated the way you came up with the answer of -1 every time, despite the complicated problems that you took on. So a very good evening to everyone present here. And on behalf of Gujarat Council on Science and Technology, it is my honor and privilege to extend my heartfelt gratitude to all those who made this Olympiad orientation program a success. First of all, I would like to express my sincere thanks to Dr. Narottam Sahu, sir, advisor of GUJCOST, for conceptualizing this program and making this program happen at the right time, and allowing the students to be motivated to get this program and be able to register for the Olympiads. My special thanks to all the subject experts, including Shirish Pathare sir from TIFR, Professor PG Kale sir from President Association of Teachers in Biological Sciences, Mr. Tejas Shah from Agnel Multipurpose School and Junior College, Dr. Amrit Krishna Mritra from West Bengal Education Service, Mr. Achyut VS from VVS Sardar Patel PU College, and of course our last speaker of this entire orientation, Dr. Udyan Prajapati sir from Xavier's College, Ahmedabad, for sharing their valuable insights and motivating our students actually to dream big and work hard towards excellence. The two of the students, the winners in the various Olympiads, Mr. Agam Shah and Mr. Rudra Pethani, they were here today with us to motivate the students, and that was actually a very motivating thing for all the students. My special thanks to all the center coordinators who will be conducting this Olympiad program, and so they also got motivated, and the students of their schools also got motivated to register as well as take part in the Olympiads. And I also thank my project directors and CSC coordinators, and as this program was live streamed across Gujarat. Thank you to students and parents for their enthusiastic participation. Special thanks to Dr. Jyotin for conducting this entire program in a seamless, coordinated manner. And I would also like to inform you that this entire session, the 2-day session, will be available on our GUJCOST YouTube channel for viewing, and we'll be sharing the link in the groups as well as broadcasting it to all the registered participants. With this, we conclude this session with a positive note and look forward to witnessing the remarkable achievements of our students in the upcoming Olympiads. Thank you, and to one and all, thank you.
Thank you everyone.